Hello there, and welcome once again to Sleep Science Space, this quiet little corner where curiosity softens into a slower rhythm and knowledge becomes something you can rest beside. Tonight, as you settle in, we're going to lift our gaze toward the gentle dark above us, this vast velvet canopy that has carried human imagination for as long as our species has known how to look up and wonder. It's a sky filled with stars, constellations, and drifting whispers of motion, but tonight there's one neighbor in particular we'll be leaning toward. A galaxy so immense that even the word enormous feels too small and yet so surprisingly close that on a perfectly clear night, your own unaided eyes can find it. The Andromeda Galaxy. It waits there in the silence, suspended just above the horizon of thought, and together we're going to spend a quiet stretch of time exploring what it truly means to ask how big Andromeda really is. Before we step deeper into that mystery, take a moment to notice where you are right now. Maybe you're tucked comfortably under your blankets, the room already dim and soft. Maybe you're in your favorite chair letting the day exhale out of your shoulders. However, the moment finds you. The sky above you, no matter the weather, no matter the time zone, is the same ancient sky seen by every generation before us. The same sky that carries the faint, patient glow of Andromeda. And perhaps you've already seen it without ever knowing its name. To the naked eye, it appears only as a gentle smudge of light, a subtle blur near the constellation of Andromeda herself. It doesn't glimmer or call attention to itself the way bright stars do. It just hangs there quietly, almost shyly, as if it understands that those who notice it will pause just a little longer, squint a little deeper, and in doing so will join a chain of observers stretching back thousands of years. Before we drift further forward, I want to ask you something simple, something small but grounding. Where are you listening from right now, and what kind of night surrounds you? Is the sky clear above your home, or is it veiled in clouds? Is the day just beginning to fade, or has midnight already wrapped the world in stillness? I ask not because the answer changes the science, but because it gently reminds us that even though your clock and my clock may not agree, even though somewhere the sun is rising and somewhere else the moon is high, we're sharing this moment together, sharing this thought, sharing this galaxy. A galaxy whose light began its journey long before humans had written a single word. If these quiet explorations bring you comfort, if you enjoy slipping towards sleep with a soft kind of science beside you, I'd be grateful if you gently tapped the like button or perhaps subscribed so this small corner of calm can drift outward to others who might need it too. Just as stars scatter across the night sky, these tiny actions scatter a little warmth across the world, and that feels like something worth offering. So take a slow breath, let your shoulders loosen, and let's ease forward into Andromeda. It is both familiar and mysterious, a galaxy so often captured in photographs and charts that it feels almost known to us, and yet one that quietly hides behind the overwhelming scale of what it truly is. When we say galaxy, we're talking about something far more expansive than a single object. We mean a vast collection of hundreds of billions of stars woven together with drifting clouds of gas, long fields of cosmic dust, invisible halos of dark matter, and a restless central core where gravity folds inward so intensely that even time seems to hesitate. Andromeda has all of that, every element, every complexity, and then more still. If our eyes were sensitive enough to gather its full glow, Andromeda would stretch across the sky many times wider than the full moon. But human vision is humble. It catches only the brightest central regions, leaving the true immensity of Andromeda to telescopes' long exposures and the slow patience of observation. So when we ask how big Andromeda is, we're really asking several questions at once. Do we measure its width, its sweeping span, from one spiral arm to the next? Do we measure the number of stars inside it? Each one a sun in its own right. Each one potentially home to planets and stories we'll never hear. Do we measure the weight of its dark matter, halo, the invisible cocoon that shapes its gravity in ways we can feel but not see? Or do we measure its nearness and its destiny, because Andromeda is not just an object in the sky? It is our cosmic neighbor close enough that the two of us are already locked together, drifting slowly toward a meeting written into the fabric of gravity itself. Big, when it comes to Andromeda, isn't just about kilometers or light years. Big is a feeling. Big is an expansion of perspective, a gentle stretching of human imagination into a shape wide enough to hold something almost beyond comprehension. If you close your eyes and think of the word big, maybe you imagine a mountain range, or the broad surface of an ocean, or the curvature of Earth seen from high above. Andromeda is larger than all of those, larger than any single comparison can hold. It's not simply bigger than something. It's big in the sense that it contains multitudes, billions of suns, countless systems, entire histories of stars rising and stars fading. To hold all of that in one thought is difficult, and yet that is exactly where our journey tonight begins. Imagine yourself standing beneath a dark enough sky somewhere far from city lights, far from noise, far from the glow of human life. Above you, the stars spill across the darkness, sharper, brighter, more numerous than you're used to seeing. And in that deeper silence, the faint oval of Andromeda appears, not as a point, not as a sparkle, but as a small, ghost like smudge, almost shy in its simplicity. And you know quietly that what you're looking at isn't a dot, it's an entire galaxy, one so enormous that your eyes can only gather a fingertip's worth of its light. That hazy blur is the combined glow of hundreds of billions of stars, all their ancient photons woven together into a single soft smear drifting into your vision. Those photons have crossed 2.5 million light years to meet you here. 2.5 million years of travel. Light gliding across nearly 10 trillion kilometers every single year, until finally, tonight, a handful of them reach your retinas. And somehow, that enormous gulf is still considered close. Andromeda belongs to what astronomers call the local group, a small neighborhood, by cosmic standards. Its nearness makes it both familiar and humbling, because what your eyes see is just the center, the bright, crowded hub where stars are densely packed. Out beyond that, glow stretching invisibly into the dark, lie the spiral arms hundreds of thousands of light years long. They cradle young stars, drifting pockets of gas where new suns ignite and lanes of dust that ripple like dark rivers across the starlight. If your eyes were tuned differently, if you could see ultraviolet or infrared the way instruments can, Andromeda would reveal even more of itself. Filaments of gas sprawling arcs of faint light, delicate structures stretching outward like cosmic lace. But here, in the soft quiet of night, Andromeda remains only a blur and a question. How big is it? Really, that is what will unravel together. Not in a rush, not through lists of numbers, but slowly and steadily, with wonder, with stillness, and with the gentle comfort that even though we're talking about galaxies, you are here to rest. Science is simply the path we take toward that rest. Because when you first hear the name Andromeda, it might sound unreachable, a distant idea reserved for astronomers with telescopes and long nights of study. But the truth is kinder than that. But in truth, Andromeda is one of the few galaxies you can meet with your own eyes. A neighbor that asks for nothing more than a clear sky, a patient moment, and a willingness to look just a little deeper into the night. That alone makes it unusual. Most galaxies are much too faint, so far away, so gently dispersed across the vastness that their light falls beneath the threshold of human vision. But Andromeda is different. It is close enough, bright enough, steady enough that if you know where to look, you can see it as a pale patch hanging above the horizon. A quiet reminder that long before we built telescopes or mapped the cosmos, our ancestors already had a direct link to a world far beyond Earth. Let yourself rest in that thought for a moment. For most of human history, the night sky was not a backdrop, it was a companion, the most reliable presence after darkness fell. Farmers learned the seasons by its patterns. Sailors trusted their voyages to its landmarks. Storytellers shaped entire mythologies from its constellations. And woven into those mythic shapes long before the word galaxy even existed was Andromeda. Seen not as a spiral, not as a cosmic island of stars, but simply as a mysterious, softened glow. Early observers gave it names tied to their legends, but across cultures and centuries, they all pointed to the same faint oval in the sky, a glow that refused to behave like a star or a planet or anything they understood. Something larger, something beyond. If you try to find Andromeda yourself, the path begins with a familiar landmark in the sky, the great square of Pegasus. From there, the constellation of Andromeda stretches outward, a princess in ancient Greek myth chained to a rock at the edge of the sea, and just off her celestial outline lies that soft oval blur. To the naked eye, it seems modest, little more than a smudge. Through binoculars, it sharpens into an elongated ellipse. Through a telescope, its spiral form begins to unfurl, arms curling outward in grand, sweeping arcs, dust lanes tracing through starlight like whispered brushstrokes. But regardless of how you view it, whether as a simple haze or a detailed spiral, what you're looking at is astonishing. a galaxy more than twice the size of our own, seen from across millions of light years. Every photon your eyes catch has traveled since long before the world around you existed in its current form. The light that reaches you tonight left Andromeda about 2.5 million years ago, back when early humans on Earth were shaping the first simple stone tools, long before cities rose, long before writing, long before anyone even knew what the stars truly were. In this way, Andromeda becomes a time capsule, a gentle bridge between now and then. Every time you look up, you are not seeing Andromeda as it is tonight, but as it once was millions of years ago. That ancient light has been traveling across expanding space, uninterrupted, unwavering, just to arrive in this quiet moment where you are listening, where I am speaking, where the world around you continues in its routines without ever knowing that a message from deep time has just brushed against your eyes. Astronomers often talk about this with a kind of reverence, the idea that light allows us to read the past written across the universe. But with Andromeda, the feeling becomes especially intimate. It is close enough to be visible, yet distant enough that we are always looking into its prehistoric story. That alone makes it feel enormous, because when your unassisted eyes meet that faint glow, they are meeting photons that have crossed millions of years, carrying the memory of a galaxy that once was. That is not simply a measurement, it is an encounter, and it is humbling. If we step back and imagine Andromeda as it truly is, far beyond what our eyes can gather, we realize how deceptive that delicate blur can be. The light you see is only the crowded central bulge, the densest heart of the galaxy. But Andromeda extends much farther. If its full disk were bright enough for human vision, the spiral would stretch across the sky many times wider than the full moon. Can you picture that for a moment? Looking upward and seeing not a faint oval, but a grand spiral galaxy spanning the heavens, arms sweeping outward as though embracing the entire dome above you. It's almost impossible to hold in a single thought, and yet, in the gentle rhythm of night, that is exactly what Andromeda becomes, a vastness softened into a single blur, waiting quietly at the edge of your vision. That is what Andromeda actually looks like. But what your eyes gather is only its core, only the brightest candle flame in a lantern, far larger than you can see. In that sense, meeting Andromeda is like greeting someone in dim light. You sense the outline, the presence, the quiet weight of something vast, but the details stay hidden until you learn how to look more deeply. This is where our instruments become extensions of our own curiosity. With binoculars, the shape sharpens. With a telescope, structure begins to reveal itself, spiral arms unfurling like slow cosmic ribbons. With long exposure photography, Andromeda blossoms into full color blues from hot young stars, golds from older stellar populations, dark winding lanes of dust where starlight is softened and scattered, faint ghost-like crescents where the outer arms stretch into the intergalactic dark. Each method of looking reveals another layer, another truth, another softness in this galaxy's enormous shape. And yet the simplest view, your unaided eye, catching that pale smear in the sky, is still the most profound, because it joins you to every human being who has ever tilted their head upward and wondered at the same blur. For a moment, across thousands of years, you stand in their footsteps. Imagine them, ancient Greek astronomers marking the strange little cloud in their star charts, Persian scholars studying its glow, the 10th century astronomer Al-Sufi describing a faint nebulous patch in his Book of Fixed Stars. Centuries later, European scientists cataloging it as a nebula, assuming it floated somewhere inside the Milky Way. For all that time, humanity believed the universe was only our galaxy, one island, one home. Then, in the early 20th century, Edwin Hubble measured the distance to this faint blur, and suddenly the walls of the cosmos expanded. Andromeda was not just a cloud within our galaxy. It was a galaxy of its own immense independent and unimaginably far. The universe once thought to be a single island was revealed to be an ocean full of them, and Andromeda was our closest neighboring shore. So seeing Andromeda with your own eyes is more than a moment of stargazing. It is stepping into a lineage of curiosity that stretches back beyond written history. The same photons touching your eyes tonight touched theirs. The same ancient light, traveling for millions of years, arriving in thousands of eras, whispering the same quiet message across time. You live in a universe far larger than you know. And Andromeda is not only a distant companion, it is a gravitational partner. The Milky Way and Andromeda are slowly, gently drifting toward each other, pulled together in a cosmic dance that will eventually merge our galaxies into one. That faint smudge in the sky is also a preview of the far future, a signpost of where our home galaxy is quietly heading across the ages. When we ask that how big Andromeda is, it helps to begin right here with this meeting. Because big is not just a number. Big is the reach of ancient light. Big is the presence of 1 trillion stars condensed into a single blur your eyes can barely register. Big is the way something so immense arrives to you as a fragile shimmer no brighter than a faint star, yet holds more worlds than your mind can comfortably imagine. Standing beneath a clear sky with cool air brushing your skin, looking at that delicate oval of light, you are encountering something that stretches about 220,000 light years across and holds nearly 1 trillion stars inside it. 1 trillion suns. And all of it reaches you as the gentlest glow. That contrast, its colossal reality versus its humble appearance, is part of what makes Andromeda so astonishing. The meeting begins here with your eyes and that faint ancient blur. But the story doesn't end with what you see, because the moment you notice it, questions begin to unfold. What are those stars made of? How far do its arms reach? How do we measure such distances? How many systems orbit inside it? How many worlds? How many skies? How many possible stories might lie there? And each of those questions pulls us deeper from the soft blur in your night sky into structures so vast they challenge the edges of imagination. Tonight, as we continue, we'll walk gently into those answers together. When we talk about the Andromeda Galaxy, it's easy to let it drift into the realm of diagrams and distant concepts. Something printed on a page, plotted on a star chart, or captured through the long exposure eye of a telescope. But pause for a moment and ask yourself, have you ever truly seen it with your own eyes? That faint oval glow above the horizon, so modest and so shy that countless people live their entire lives without ever noticing it. Because the truth is quietly astonishing. Without any telescope at all, without technology or training, your own eyes are capable of collecting the ancient light of a galaxy 2.5 million light years away. Light that began its journey long before human beings learned to write, long before cities rose, long before stories were placed into constellations. And yet, despite this accessibility, Andromeda often remains a name rather than an experience, something people have heard of but never sought in the sky. Perhaps you've stepped outside at night and recognized the bold, familiar constellations, Orion's unmistakable belt, the Big Dipper's shining ladle, Cassiopeia's bent W glimmering against the dark. These are the shapes that call attention to themselves, the easy landmarks of the night. Andromeda's glow is something else entirely. It is quiet, gentle, a presence that never insists. You have to look for it deliberately, and sometimes you even have to look slightly away from it, using the sensitivity at the edges of your vision in the place where your eyes gather faint starlight more readily. Stargazers call this technique averted vision, a simple but ancient way of seeing what isn't meant to be seen directly. And when you finally catch it, that pale ghost-like blur, the experience is subtle but deeply affecting. You realize you're not just looking at a faint patch of light. You are looking at the combined glow of hundreds of billions of stars softened and blended together by distance. The humility comes from recognizing how tiny your eyes are compared to the scale of what they're touching. The wonder comes from realizing that despite that smallness, you are still able to meet something so immense. You don't need a spacecraft. You don't need a laboratory. You don't need a telescope worth a fortune. All you need is darkness, a patch of open sky, and a little patience. That accessibility is part of Andromeda's quiet magic. If you've never had that experience yourself, imagine it now. Picture yourself standing far from the wash of city lights, maybe in a quiet field, or beside a still lake, or on a mountain where the air feels thin and crisp against your skin. Above you, the stars bloom brighter than you've ever seen them. The Milky Way spills across the sky like a pale river made of dust and distant suns. And there, tucked gently beside it in the constellation of Andromeda, is a smudge. It looks almost like a fingerprint brushed lightly across a pane of glass. Oval, faint, humble, something you might dismiss in the blink of an eye if you didn't know what you were searching for. But you stop. You let your gaze soften, your eyes adjust. Slowly the smudge becomes clearer. That is Andromeda. That is another galaxy. That is light that has been traveling for 2.5 million years, arriving now in this exact moment to meet your eyes. For many people, that first encounter feels strangely personal, different from seeing a photograph, no matter how beautiful. A photograph can reveal details the human eye will never capture. The blues of young star clusters, the golds of ancient stellar populations, the delicate dust lanes ribboned across its arms. But photographs are mediated, processed, filtered, framed. Seeing Andromeda with your own eyes is something else entirely. It is not about clarity. It is not about detail. It is about connection, a direct, unbroken line between you and a world so distant that its light began traveling when no human language yet existed. And yet here it is, brushing the back of your retina like a whisper. It reminds you that you are part of a universe vast beyond comprehension, and yet somehow gently, intimately accessible. You're standing beneath the same sky ancient astronomers once traced onto parchment with trembling ink, the same sky sailors trusted as they crossed dark oceans, the same sky storytellers wove into myths by firelight. And somewhere within that shared dome of night, countless people through history paused and wondered about that faint, quiet blur, Andromeda, long before they knew what it truly was. It's a little startling to realize how many of us move through our entire lives without knowing we can see another galaxy without any help at all. The night sky has faded for most people, washed out by neon, buried beneath streetlights, softened by haze and buildings. But even now, even in our electrified world, Andromeda is still shining. Its photons continue falling on rooftops, on windshields, on sleeping neighborhoods, arriving night after night, whether anyone is looking or not. To actually notice them, to pause long enough to let your eyes adjust, is to reclaim something ancient, something soft and quiet, a moment of connection older than language. People often describe the experience in deeply personal terms. Some say it makes them feel small, but not in a frightening way, more like a gentle release, as though all their worries shrink against the backdrop of a universe too vast for stress to survive. Others say it makes them feel strangely included, part of a cosmic network where even their brief human life is a thread woven through something immeasurably larger. There are even people who find it grounding, and there's a beautiful paradox in that. By looking at something impossibly far away, they feel more anchored right where they stand. It helps to remember that the light from Andromeda doesn't arrive in one grand wave. Every second, new photons are completing their long journey, slipping across the void and touching Earth. The light you see tonight is not the same light you saw last night. It is all ancient, but it is always arriving, always renewing itself. Seeing Andromeda is not a single moment. It's a quiet, ongoing relationship with signals that have been traveling since early humans shaped their first tools. Maybe you're listening from a city where the sky is hazy and pale, where only the brightest stars break through the glow. Maybe you've never seen Andromeda and wonder if you ever will. That's all right. Even if the sky above you is washed in orange or silver gray, Andromeda hasn't vanished. It's still there, patiently shining. It's simply hidden by what we've built around ourselves. But if you ever find yourself beneath a darker sky, on a trip, on a hike, on a quiet night far from the city, remember this moment. Step outside. Breathe. Let your eyes soften. Give them time. And look for that quiet oval of light. You might have to search a little, but the reward is quietly incomparable. Astronomers often define Andromeda with numbers about 220,000 light years wide, almost a trillion stars drifting toward us at roughly 110 kilometers per second. These facts matter. They help us understand the galaxy's shape and motion. But none of these numbers can explain what it feels like to see it yourself. No measurement captures the soft astonishment of finding that pale oval suspended in the dark and knowing truly, knowing that it isn't a cloud or a trick of your vision, but an entire galaxy, an island universe, a home for stars, planets, and stories we can't yet imagine. You don't need to be a scientist to feel that moment settle into you. You don't need formulas or diagrams. The experience is human, universal, something our earliest ancestors and our modern minds still share. And perhaps that's why asking whether you've ever seen Andromeda really matters. If you have, you already know the quiet thrill that rises inside you when that blur resolves into meaning. And if you haven't, then the thought of one day seeing it becomes its own kind of promise, a small, gentle adventure waiting somewhere in the night. There is something grounding in remembering that the sky is still full of wonders that don't require screens or devices. Andromeda is the greatest of these open air wonders, a neighboring galaxy visible without a lens. Pausing to seek it out is a gift you give yourself, a shift in scale from human worries to cosmic time. To someone walking past you, nothing unusual would be happening. They might not notice the subtle way your breath stills or the way your eyes soften toward that faint glow. They might think you're simply stargazing, but inside you, something enormous is unfolding. You are bridging millions of years and millions of light years with your own eyes. You are touching another galaxy, and that transformation, quiet, internal, invisible to anyone but you, is what turns a faint blur into a genuine cosmic encounter. So let me ask you once more, gently, have you ever truly seen it with your own eyes? Have you ever stood beneath the stars long enough for that soft glow to reveal itself? If you have, you might remember the exact moment, whether the air was cool against your skin, whether you were alone or in quiet company, whether the night felt young or half asleep. Those details tend to linger because meeting another galaxy with nothing but your unaided vision is the kind of experience the mind saves in a special place. And if you haven't seen it yet, that's perfectly all right. The next time you find yourself beneath a dark, open sky, maybe on a trip, maybe during a power outage, maybe on an unexpected clear night, you'll carry this quiet awareness with you. And when that faint oval finally appears, you'll know instantly what you're looking at. Another spiral galaxy, the nearest great one to the Milky Way, and a future dance partner in a slow motion gravitational encounter billions of years in the making. In the end, meeting Andromeda isn't a task for astronomers or a privilege reserved for telescopes. It's a moment of presence, a moment when you let yourself feel both astonishingly small and quietly vast at the same time. And once that awareness settles in, the natural questions begin to rise. If your eyes can gather the light of a whole galaxy, what exactly are you seeing? How many stars does that blur contain? How far do its arms reach? And how on earth do we measure something so huge? The moment you realize that your vision can touch another galaxy, the next thought almost always arrives. Just how big are galaxies anyway? We use the word easily as if galaxies were simply oversized stars or overgrown clusters. But a galaxy is not a bigger version of something familiar. It's a scale breaker, an entity so enormous that the human mind has to stretch far beyond its usual limits just to begin imagining it. Calling a galaxy big almost feels like calling the ocean damp, technically true, but nowhere close to capturing what it really is. Consider our own Milky Way. It holds perhaps 400 billion stars. Each star is a massive sphere of nuclear fire shining across unimaginable stretches of time. Many of them host planets, rock worlds, gas giants, icy moons, dusty rings. And in between all of these stars lies not empty space, but a vast sea filled with drifting gas, microscopic dust, tangled magnetic fields, radiation, and the mysterious scaffolding of dark matter. All of this together makes a galaxy. And yet, despite its grandeur, the Milky Way is merely average, respectable, yes, but modest beside giants like Andromeda. When astronomers talk about Andromeda's size, we often begin with something simple: its diameter. The bright disk of the galaxy spans roughly 220,000 light years. Imagine traveling at the speed of light, the fastest speed nature allows, and even then, it would still take you 220 millennia to cross from one side to the other, and that's just the bright visible part. Wrapped around Andromeda is a vast, invisible halo of dark matter, a ghostly structure that may extend close to 1 million light years outward, shaping the galaxy's gravity and helping hold its stars in their long, graceful orbits. Sometimes it helps to compare. Our entire solar system, including the distant Oort cloud, where icy comets drift in deep freeze spans, maybe 2 light years across. 2. Andromeda could hold that entire distance not once or 10 times, but more than 100,000 times across its width. On paper, it sounds like math. In the mind, it feels like standing at the base of a quiet, endless cliff. Another way to approach its size is by counting stars, or at least trying to. Andromeda likely contains close to 1 trillion of them. That's 1,000 billion suns. If you tried to count one star every second without stopping, without sleep, it would take more than 30,000 years just to finish. And by the time you reached the end, new stars would have been born, old stars would have faded, and your count would already be out of date. Each of those stars is a sun in its own right. Each may host worlds. Some could be barren, some icy, some molten, and some, maybe a rare few, might hold oceans, clouds, mountains, seasons, and mysteries we will never touch. And remember, Andromeda is just one galaxy, one among hundreds of billions inside the observable universe, each one with its own stars, its own planets, its own stories, written in light. Just thinking about that can feel like drifting outward into something too wide to measure, but in a soft way, in a way that frees the mind rather than overwhelms it. And that is where our journey continues. This is where the scale of things begins to slip out of our hands, where the mind quietly stretches and then stretches again. Because when we talk about Andromeda, we're not talking about a single object floating alone in the dark. We're talking about one layer in a nested architecture of cosmic structure. Inside it, stars cluster into families. Those families wind together into spiral arms. The arms form the body of a galaxy. That galaxy drifts inside the local group, a neighborhood of roughly 50 galaxies bound by gravity. And the local group itself belongs to the Virgo supercluster, which is only one thread inside an even larger cosmic web, vast filaments of galaxies spanning the observable universe like a shimmering lattice. Each level expands outward, larger than the last, each one dwarfing the one before it. And yet here we are, sitting in the stillness of evening, trying to hold all of that in a single thought, starting from the faint smudge of light visible to the naked eye. Sometimes it helps to shrink this immensity into an image we already understand. Imagine Earth as a single grain of sand. Now imagine every beach on the entire planet, every coastline, every dune, every hidden cove, each grain representing a star. Even that isn't enough to capture the stars inside Andromeda. And then remember, Andromeda is just one galaxy among countless others. What feels impossibly grand to us is at the scale of the universe, astonishingly ordinary. Astronomers often lean on metaphors not because they prefer poetry, but because numbers alone break under this weight. So they'll say that if our solar system were the size of a coin, Andromeda would be the size of a continent, or that if the Milky Way were the size of a dinner plate, Andromeda would be another plate sitting beside it, and the observable universe would be the size of Earth, filled with plates in every direction. These visual tricks aren't meant to be perfect. They're meant to give the mind a foothold, something to hold on to while it tries to understand structures far beyond daily experience. No matter how you frame it, though, the truth remains unchanged. Galaxies are colossal, and Andromeda is large enough that when you look at it in the sky, you're seeing something that language strains to describe. For many people, this first glimpse of scale shifts something inside. Our lives unfold in human dimensions, seconds, minutes, years. Our history spans centuries, even when we stretch our imagination to the rise and fall of civilizations. We're still talking about tens of thousands of years. Galaxies operate on completely different scales, hundreds of thousands of light years, billions of years of evolution, cosmic time scales that make human time feel like a whisper. And yet, in that whisper here, we are looking up, asking questions, noticing the glow of a galaxy so far away that its light began traveling toward us long before humans existed. It's worth remembering how long it took us to even understand what we were looking at. For centuries, Andromeda was cataloged as a nebulous cloud believed to be part of our own Milky Way. It wasn't until the 1920s that Edwin Hubble measured its distance and shattered that assumption. Suddenly, the universe grew overnight. The Milky Way was no longer the entire cosmos. It was just one island among many islands in a sea of unimaginable depth. That faint smudge was revealed to be a sprawling realm of its own, with its own stars, its own planets, its own stories unfolding over billions of years. And the immensity of the galaxy isn't just about its size, it's about time. Stars inside Andromeda have been burning for ages that stretch back farther than Earth's own history. Whole generations of stars have lived and died forging the heavy elements that make planets, oceans, and living beings possible. When you look at Andromeda, you're seeing one moment in that long story, a single frame in a film that began long before us and will continue long after our own sun fades. This is what makes the scale feel both humbling and intimate at once. Humbling because our lives are brief, delicate sparks against a backdrop of billions of years. Intimate because we are made of the same elements born in ancient stars. The atoms in your breath, your bones, your heartbeat, they were forged in stellar furnaces, not unlike the ones inside Andromeda. The immensity of galaxies isn't something distant or detached, it's something we belong to. Andromeda is enormous, but the materials that shape it are the same materials that shape us. We're not separate from the cosmos. We're expressions of its small, temporary conscious and full of wonder. When you look toward Andromeda, what you're really catching is the doorway into something far larger than the eye can hold a first soft glimpse into the true architecture of the universe. Even though the light appears faint, almost fragile, it hints at a scale so immense that a single human thought can barely grasp it. And that small glimpse is enough to stir the deeper questions, the kind that keep us awake at night or lull us gently into wonder. If one galaxy can be this vast, what does that say about the others? If our Milky Way is only one among billions, where exactly do we fit in that ocean of stars? How do we measure our place when the measuring stick stretches farther than imagination? These questions don't ask for quick answers. They ask only to be held slowly, patiently, because the immensity of galaxies begins right there with the realization that the faint patch of light in the night sky is actually an entire realm of its own, a place hundreds of thousands of light years wide, holding nearly a trillion suns wrapped in a halo of unseen dark matter that reveals itself only through the gravity it exerts. That is the first taste of scale, overwhelming, humbling, and strangely soothing all at once. And once we feel that enormity, the natural curiosity follows. If Andromeda is this enormous, how does it stand beside our own galaxy? In what ways do they resemble each other, and where do they diverge? What do those similarities and differences reveal about the nature of galaxies themselves? Because despite the instinct to imagine Andromeda drifting alone in the void, galaxies rarely travel in isolation. They gather into families, cosmic communities, bound together by gravity, forming groups and clusters that drift through space as interconnected neighborhoods. Andromeda, vast as it is not wandering alone. It resides within a small but meaningful family of galaxies called the local group, and within that family, it holds one of the central roles. The local group, by cosmic standards, is modest. It holds more than 50 galaxies, though only a handful are large. The others are tiny companions, dwarf galaxies, that swarm around the bigger spirals, like small boats circling massive ships. At the heart of this collection are two major spirals, our Milky Way and Andromeda. They are the giants of this region, their gravitational influence shaping the motions and destinies of nearly everything else nearby. A third notable player, the Triangulum Galaxy, contributes to this gravitational conversation, though it is smaller and lighter than the other two. Together, these three form the backbone of our cosmic neighborhood, with Andromeda taking the crown as the largest and most massive of them all. To visualize this, imagine the local group as a quiet town spread across a wide, dark valley. Most of the homes are small, simple cottages scattered gently across the landscape, but here and there stand a few enormous mansions sprawling and unmistakable. Those mansions are the Milky Way and Andromeda. They set the tone of the neighborhood, their size and mass, tugging on everything around them. The smaller houses, the dwarf galaxies, cluster near them, orbiting gently, like families living close to their towering neighbors. Some of these dwarfs circle the Milky Way, like the small and large Magellanic clouds visible in the southern sky. Others move around Andromeda, including M32 and M110 small elliptical galaxies that hover close like tiny companions walking beside a much larger figure. When astronomers map the local group, Andromeda appears roughly 2.5 million light years away on one side, with the Milky Way on the other. A deep gulf of space stretches between them, yet their gravitational attraction is strong enough that they are slowly drifting toward each other. Triangulum sits not far from Andromeda, possibly orbiting it, possibly orbiting the group's center of mass, depending on which model you follow. And the rest of the local group's members fall into place around these giants, each shaped by their collective pull. The whole group spans around 10 million light years, a distance that feels impossibly huge to us, and yet compared to the larger clusters beyond it, is humble, ordinary, a quiet suburb on the edge of a cosmic metropolis. Andromeda's presence in the local group isn't simply that of a participant drifting among the others. It sits there as the heavyweight of the neighborhood, the quiet giant whose gravity extends farther and pulls harder than any other member around it. When astronomers measure its mass, including the enormous halo of dark matter that surrounds it, they find that Andromeda outweighs the Milky Way by something on the order of 30 to 50%. The numbers shift as new measurements refine our understanding, but the picture remains the same. Andromeda carries more weight, and that extra mass gives it a deeper gravitational well, a larger sphere of influence, and a more commanding role in shaping the motions of the galaxies around it. When scientists simulate the future of the local group, the story that unfolds is both majestic and inevitable. The Milky Way and Andromeda, separated now by roughly 2.5 million light years, are slowly drifting toward one another. They are locked in a long-term gravitational embrace, closing the distance centimeter by centimeter, year by year. In about 4 billion years, the two giants will meet, merging their stars, clouds, halos, and histories into a single, even larger galaxy. That collision will reshape the local group, entirely blending the structures we see today into a new cosmic form. It sounds dramatic, but on cosmic timescales, it is simply the next step in a long dance. Before imagining that far-off future, it helps to turn our attention to the smaller members of the group, those faint dwarf galaxies that often escape notice. Many of them are so dim, so spread out, that they've only been discovered in recent decades through deep, sensitive surveys. Compared to Andromeda's trillion stars, Some of these dwarfs contain only a few billion. A handful contain even fewer. Their shapes vary. Some are oddly irregular, like scattered smudges of starlight. Others are smooth round ellipses, lacking the spiral structure of their larger cousins. They orbit close to the giants, and because they are small, they are easily shaped, stretched, and sometimes slowly torn apart by the gravitational pull of the larger galaxies. These tiny companions remind us that galaxies exist across a broad spectrum of size and complexity, and that the local group is not just defined by its massive centers, but also by the quiet interplay of the small with the large. Andromeda's presence gives the local group a sense of balance, a two giant system rather than a single galaxy domain. Without it, the Milky Way would dominate almost everything. With it, the group becomes a two anchor structure, a paired system whose shared gravity influences the trajectories of dozens of smaller galaxies. Their mutual pull shapes the future of the group. Their eventual merger will set its destiny. Understanding Andromeda is not only about studying a galaxy in isolation, it is about learning how galaxies coexist, how they cluster, how they tug on one another across millions of light years, and how they evolve together. Astronomers often treat the local group as a kind of cosmic laboratory. Because it is nearby, the galaxies within it can be studied with far more detail than distant clusters. By comparing the Milky Way Andromeda Triangulum and the scattered collection of dwarfs, scientists test theories about how galaxies form, grow, age, and interact. They watch how smaller galaxies are absorbed. They track how star formation changes in different environments. They examine how dark matter shapes the motions of entire systems. In this way, Andromeda's role becomes something more than positional, it becomes educational. It is one of the foundational pieces that helps us understand what galaxies are and what they become. There is something quietly comforting in knowing that galaxies naturally gather into groups like this. The local group is only one of countless such associations scattered across the universe, each held together by gravity, each part of the intricate cosmic web that makes up the large scale structure of the cosmos. Andromeda's proximity makes it feel almost familiar, an immense but approachable neighbor. Even though it is another galaxy entirely, it sits close enough to become part of our story. If you picture again that faint blur in the night sky, the one you might see with your own eyes on a moonless night, it becomes even more extraordinary when you realize what it represents. Not only is it a galaxy hundreds of thousands of light years wide, it is also the largest galaxy in a community that contains more than 50 members. It is the gravitational anchor of its side of the group, the counterpart to the Milky Way, the partner in a slow motion meeting billions of years in the making. Andromeda's place in the local group is defined not just by its size, but by its role as neighbor, as partner, as co architect of our cosmic environment. Together, these two great spirals shape the future of the space around them, the corner of the universe we quietly call home. And when we turn to compare our Milky Way with Andromeda, something interesting happens. It becomes clear that the galaxy we inhabit, the one we instinctively use as our standard, is only one version of what a galaxy can be. The Milky Way is a barred spiral galaxy with a central bulge elongated by a bar-shaped arrangement of stars. From that bar, sweeping spiral arms extend outward in graceful arcs. Andromeda is also a spiral, but its internal architecture differs. Its central bulge is rounder, more dominant. Its arms are broader and less tightly wound, and any central bar it might possess is far less prominent than ours. Both galaxies contain immense amounts of gas dust and stars. Both host families of satellite galaxies. Both rest within halos of dark matter that extend far beyond the visible disks. But in many of the metrics, we can measure diameter, star count, total mass. Andromeda appears to be the larger. Its disk spans roughly 220,000 light years, nearly twice the estimated width of the Milky Way. Its star population approaches a trillion, far more than the roughly 400 billion in our galaxy. And though dark matter makes mass hard to measure, precisely many studies suggest that Andromeda outweighs the Milky Way by about a factor of 1.5. These differences matter because they reveal something subtle. Galaxies are not identical objects stamped out in cosmic repetition. They are unique, shaped by their histories, their mergers, their environments. Andromeda's size, structure, and mass tell a story of what our own galaxy might once have been, or what it may become billions of years from now. Even so, astronomers still tend to place Andromeda at the top of the local group's hierarchy. Its extra mass gives it a stronger gravitational voice, a deeper pull, a wider reach, but that doesn't mean the Milky Way is merely a smaller reflection of its neighbor. Our own galaxy carries its own personality, its own rhythms, its own quiet strengths. The elongated bar at its center acts almost like a cosmic river funneling stars and gas inward, shaping the flow of material across the core and influencing where new stars ignite. And while Andromeda may outnumber us in stars, the Milky Way seems to be the livelier of the two. Its star-forming regions are more active, birthing new suns at a slightly faster pace, giving our home galaxy a youthful spark in contrast to Andromeda's heavier, more settled presence. Our collection of satellites also paints a different picture. South of the equator, the large and small Magellanic Clouds sweep through the sky as luminous clouds, two of the most prominent dwarf galaxies in our neighborhood. Andromeda has companions of its own, but ours are easier to see, easier to connect with. The deeper you look, the more the differences multiply. At the center of both galaxies lies a supermassive black hole, a silent engine shaping the motions around it. In the Milky Way, that black hole is Sagittarius A, a compact monster about 4 million times the mass of the Sun. Andromeda's central black hole is vastly larger, around 100 million solar masses, giving it a more commanding gravitational anchor at its core. Despite that enormous difference, Andromeda's black hole appears relatively quiet, not gulping down large amounts of matter at the moment, making it far calmer than the blazing active nuclei seen in some galaxies. Their spiral arms tell another story. The Milky Way's arms are more loosely coiled, giving our galaxy an airy, open structure. Andromeda's arms sweep outward in broad swaths, heavy with dust lanes, and embedded star clusters. In photographs, those arms look more dramatic, thicker, darker, more sculpted by past interactions. And indeed, both galaxies show evidence of having swallowed smaller galaxies across their histories. Our Milky Way carries stellar streams, long, faint threads of stars left behind by ancient mergers. Andromeda's outer halo is filled with similar debris, the remnants of galaxies pulled apart by its gravity over billions of years. These past interactions don't just shape how each galaxy looks, they influence how each one moves, how their orbits shift, how their halos overlap, how their futures unfold. When you compare Andromeda and the Milky Way, it can be tempting to imagine them as cosmic rivals, two great cities competing on opposite sides of a vast dark highway. But the truth is gentler and more intertwined. They are partners in a shared gravitational story. Their combined mass shapes the motions of dozens of smaller galaxies. Their satellites circle in patterns influenced by the tug of both giants. Their destinies are already threaded together, slowly pulling them toward a collision that will blend their stars, halos, clouds, and histories into a single new galaxy. So, while Andromeda may be larger, and the Milky Way perhaps more energetic in star formation, the real significance lies in their connection. Their relationship is the bridge that links our home to the wider structure of the local group. And in seeing that relationship clearly, something shifts in how we imagine our place in the universe. It reminds us that our galaxy is not the ultimate expression of cosmic architecture, just one variation, one design among many, shaped by its own past and carried toward its own future. If Andromeda's central black hole outweighs ours, it nudges us to consider just how wide the spectrum of galactic possibilities truly is. And if the Milky Way forms stars at a brisker pace, it reminds us that sheer size isn't the only measure of significance. Sometimes vitality, motion, and renewal carry their own kind of importance. Each contrast between the two galaxies adds another layer to our understanding of what a galaxy can become. Another gentle difference lies in how we see them. The Milky Way. Our home stretches overhead as a hazy river of starlight because we live inside its disk. We're immersed in its structure, surrounded by its arms, looking outward from one of its suburbs. Andromeda, by contrast, is something we see from the outside, tilted just enough for its spiral form to reveal itself as a whole. That shift in perspective matters. Being inside the Milky Way means we cannot simply step back and take a photograph of it. Instead, we reconstruct its shape from the motions of stars, the maps of hydrogen clouds, and the subtle fingerprints of gravity. But Andromeda, distant yet clear, gives us an external mirror. By studying its structure, we glimpse what our own galaxy might look like to eyes watching from afar. Their environments also carry quiet stories. Both galaxies sit within the same local group, surrounded by families of dwarf companions orbiting under their combined gravitational influence. But their satellites aren't identical. Andromeda's closest neighbors include M32 and M110 smooth elliptical companions nestled near its glow, along with a growing list of faint dwarf galaxies discovered in recent surveys. The Milky Way's entourage includes the large and small Magellanic Clouds, dramatic and irregular companions, visible from the southern hemisphere, as well as many smaller, dimmer dwarfs, barely distinguishable from the background sky. Comparing these satellite systems helps astronomers explore how galaxies gather companions, how they keep or lose them, and how those relationships shape their long term evolution. Some dwarfs are torn apart, leaving tidal streams. Some orbit intact for billions of years. Some fall inward and become part of the larger galaxy. Each companion tells a chapter of both galaxies' shared history. Perhaps the most humbling part of comparing the Milky Way with Andromeda is how much remains uncertain. Measurements of their total mass, their exact structures, and their past interactions continue to shift as new observations refine our models. These uncertainties aren't shortcomings. They're reminders that galaxies are not frozen sculptures. They're living, evolving systems, changing slowly but continuously reshaped by gravity, time, and history. And our understanding grows in the same way, gradually, patiently, layer by layer. So when you hold both galaxies in your mind side by side across an imaginary dark canvas, you don't see a competition or a ranking. You see two variations of the same cosmic idea, two expressions of spiral architecture formed under slightly different conditions. Each carries its own rhythm, each carries its own story, and together they define the structure of our little corner of the universe. The comparison doesn't diminish either one. Instead, it expands our appreciation for the range of what galaxies can be and for the rare gift of having not one, but two grand spirals close enough for us to study in such detail. When you look up and notice that gentle smudge of Andromeda, it's almost unbelievable to imagine that anyone could ever measure something so far away, something so soft edged, so faint, so impossibly large. How could we possibly know its distance, or how many stars it holds, or how much hidden mass lies inside its halo? These questions feel like they belong to scales far beyond human senses. And yet, slowly, patiently, astronomers have learned to translate the unreachable into something we can quantify. They've built tools that turn faint light into information, turning a blur in the sky into measurable reality. The starting point for almost everything is light itself. Light is the bridge. It travels across the dark between galaxies and lands here on Earth, carrying secrets from its long journey. Every photon brings a message: how hot its star was, what clouds it passed through, how fast its source is moving, and how far it has traveled. From these tiny messengers, astronomers have crafted an entire language of cosmic measurement. It begins with brightness. Whenever you see something shining in the sky, a star, a nebula, a far off galaxy, its brightness is a mix of two ingredients: how luminous it truly is and how far it lies from us. The farther it is, the dimmer it appears. Because of this relationship, if we can find objects whose true brightness we already know, we can use their apparent faintness as a kind of ruler. These objects are called standard candles. One of the most important types of standard candles are Cepheid variable stars. These stars rhythmically brighten and dim, pulsing like cosmic heartbeats. And crucially, their pulse rate reveals their true luminosity. The longer the cycle, the brighter the star actually is. By measuring the timing of these pulses and then comparing that true brightness to what we see from Earth astronomers can deduce their distance with remarkable precision. This was the very method Edwin Hubble used a century ago to show that Andromeda wasn't a cloud inside the Milky Way at all, but an entirely separate galaxy unimaginably distant. He found Cepheid variables in Andromeda, measured their rhythms, and from that calculated how far away the galaxy must be. That single insight reshaped the universe overnight. Over time, new tools have joined the list. Supernovae, especially, type IS supernovae act like powerful cosmic beacons. Their explosions shine with a near uniform brightness, making them excellent distance markers even across enormous stretches of space. Astronomers have observed these brilliant flares in Andromeda as well, using them to refine its distance to an even greater accuracy. Another method looks at the color of the galaxy's light. As the universe expands, distant objects have their light stretched toward the red end of the spectrum, a phenomenon called redshift. But Andromeda is unusual. Instead of being stretched, its light is shifted slightly toward blue, meaning it is moving toward us. Measuring this blue shift tells astronomers Andromeda is approaching at about 110 kilometers per second. This motion is part of the long, slow gravitational drift that will eventually pull our two galaxies together. Size, too, can be measured with a combination of angle and distance. From Earth, Andromeda covers a certain width in the sky, although much of it is too faint for our eyes to pick up. Once you know the galaxy's distance, that angular width becomes a physical size. Through this kind of calculation, astronomers estimate that Andromeda's disk spans roughly 220,000 light years. A simple idea on paper, but one that relies entirely on accurate distance measurements. Another reason Cepheid variables were so revolutionary. And then there is mass. Mass can't be seen directly, even with the best instruments. Instead, astronomers measure it through motion. The stars within a galaxy orbit around its center, and their speeds reveal the gravitational pull acting on them. The faster they move, the more mass must be holding them in place. By mapping the motions of stars and gas clouds in Andromeda, scientists can calculate how much matter lies within its spiral arms, in its central bulge, and in the vast halo that surrounds it. What astronomers discover again and again is that the stars we can see, the glowing ones, scattered through Andromeda's disk, make up only a thin sliver of its total mass. The gas we detect, the clusters we map, even the bright inner bulge, all of it accounts for only a small portion of what's truly there. The rest is invisible. The rest is something we cannot see directly, but can feel through gravity's subtle pull. This is where dark matter enters the story. When scientists trace the motion of stars on the outskirts of Andromeda, they find something surprising. Those distant stars orbit the galaxy's center far faster than they should if only the visible matter were pulling on them. According to the laws of gravity, those stars should drift outward and escape. But they don't. They remain bound, moving in silent, steady loops. The only explanation is that Andromeda is embedded in a massive unseen halo, a vast cocoon of dark matter outweighing its visible stars many times over. As technology has advanced, the precision of these measurements has sharpened. Telescopes on mountaintops track tiny shifts in starlight. Space based observatories resolve stars in Andromeda individually, letting us watch their motions with clarity unimaginable a century ago. Instruments like the Hubble Space Telescope haven't just given us beautiful pictures, they've given us data, the kind that lets astronomers measure, compare, and refine. With every new observation, the outlines of Andromeda's structure grow clearer. Its mass, its size, its halo, each becomes a little less mysterious. But certainty is rare in astronomy. Measuring a galaxy is never a perfect act. It's a blend of observation and interpretation of models tested against evidence. Andromeda might be slightly heavier than current estimates or slightly lighter. Its diameter might stretch a bit farther or contract depending on how faint its outer regions truly are. Dark matter itself remains an open question: what it is, how it behaves, how it shapes a galaxy from the shadows. So every measurement is provisional, a best understanding built from the tools we have. Beyond direct measurement, astronomers lean on comparisons. By studying spiral galaxies near and far, they build a sense of what typical star formation looks like, how rotation curves behave, how halos distribute mass. By examining Andromeda's dwarf companions, the tiny galaxies orbiting around it, they learn how strong its gravitational influence must be to shepherd them through space. Each fragment of data becomes another puzzle piece, slowly forming a clearer picture of Andromeda's true scale. And when you step back, it's astonishing how much we've learned from something that appears to the naked eye as nothing more than a faint blur. Across millions of light years, light carries its messages faithfully. By reading those messages, brightness, color, motion, structure, astronomers have turned that distant smudge into something quantifiable. We know its distance, we know its size, we have estimates for its mass, including the vast dark halo that surrounds it. We can even predict its future path and understand that it's drifting toward us slowly but surely on a time scale of billions of years. All of this is possible because humans have learned to decode light and because generation after generation built the tools needed to read it. Ancient skywatchers first noticed the blur. Medieval astronomers recorded it. Early scientists debated its nature. Then came the breakthroughs. Cepheid variables revealing its distance, spectroscopy, revealing its motion, telescopes resolving its stars. Each step was small on its own, but together they transformed Andromeda from a mystery into a well characterized neighbor. And yet, the numbers, remarkable as they are, never erase the wonder. Saying 2.5 million light years is simple. Feeling the truth of that distance is something else entirely. Saying 1 trillion stars is easy. Imagining a trillion suns, each with its own story, its own worlds, its own arc through time, is almost impossible. The measurements give us clarity, but they also expand the mystery. Knowing more has not made Andromeda smaller. It has made it feel even larger. So, whenever you look up and notice that pale glow above the horizon, remember what lies behind it. Remember that its distance was measured through the pulses of ancient stars, that its motion is encoded in a delicate shift toward blue, that its size comes from the angle it paints across our sky, that its mass is hidden in the way its stars race around its center. Something that seems immeasurable has piece by piece become knowable. And all of this leads us quietly toward the next step in our journey. If Andromeda is so vast, so structured, so full of motion and mystery, how do we begin to understand the architecture inside it? How do we make sense of those graceful spiral arms, those elegant curves that sweep outward like the strokes of a cosmic brush? Because the spiral arms are not just decoration, they are the living dynamic heartbeat of the galaxy. To describe the shape of Andromeda is to shift from the idea of sheer size into something more intimate, its architecture, its patterns, the way its form expresses the story of what it has been and what it is still becoming. When you look at detailed images captured through powerful telescopes, the first thing that rises out of the darkness is the glowing bulge at its core. This central region is densely populated with older stars radiating a soft golden light that hints at age and stability. From this bright center, Andromeda's spiral arms unwind outward in grand sweeping arcs. These arms are not delicate ribbons. They are broad layered structures woven with stars, threaded with dust, and enriched with long lanes of gas. In true color photos, the arms appear mottled streaks of blue, marking clusters of hot young stars, darker bands where dust absorbs starlight, soft washed out regions where older stars provide a steady glow. These contrasts don't just make Andromeda beautiful, they reveal its inner workings. And the arms themselves, they are not rigid, permanent formations. They are patterns waves that travel through the galaxy's disk. Stars drift in and out of the arms like cars slipping through a traffic jam, while the congestion itself stays in place. This idea, known as density wave theory, explains why the arms remain coherent for billions of years without winding up into tight spirals. It isn't the same stars holding the shape. It's a persistent pattern formed by gravity motion and the distribution of matter. Inside these spiral arms, starbirth is constantly underway. Clouds of gas collapse under their own weight, igniting nuclear fusion in new stars. These newborns shine fiercely and briefly, their light blue and youthful. They live fast, burn bright, and fade quickly. Their brilliance marks the spiral arms vividly. Nearby glowing regions of red and pink reveal hydrogen clouds energized by ultraviolet radiation from those hot young stars. These are stellar nurseries, places where the galaxy replenishes itself. Threaded through these bright patches are dark, dusty lanes. They look like shadows, but they are reservoirs of creation, cold gas, and dust waiting for the right conditions to collapse, eventually forming new stars. Without these lanes, Andromeda's arms would be bright, but sterile. With them, the arms become ecosystems of ongoing change. The structure of the arms isn't perfectly symmetrical. One arm may be broader, another slightly distorted, another broken into segments. These irregularities often come from gravitational encounters. Andromeda lives alongside several smaller companion galaxies, and their close passes tug at its disk, stir up its arms, and set off new waves and clumps. Over millions of years, these interactions leave subtle fingerprints, bends, knots, arcs that record the galaxy's encounters. If our eyes were far more sensitive, if human vision could gather faint light the way cameras and telescopes do, Andromeda's full disk would appear enormous in our sky, not as a tiny blur, but as a majestic spiral stretching wider than the full moon many times over, a visible whirlpool of stars, dust, and motion painted across the night. The galaxy we know is always this vast. It is only our eyes that fall short. Beyond the bright spiral arms lies another quieter structure, the halo. This halo is an enormous sphere of faint stars, ancient clusters, and most intriguingly, streams of stellar debris. These long arcs of stars are the remnants of smaller galaxies that Andromeda absorbed in the past. As Andromeda consumed these companions, it stretched their stars into thin, ghost like trails that still orbit in the outskirts. These streams are evidence that the galaxy is not static. It grows by interaction, it remembers its collisions. Its shape today is the product of billions of years of encounters, mergers, and slow gravitational sculpting. So the true structure of Andromeda extends from its bright central heart to its faint and ancient halo, from its active star-forming arms to the fragile outer streams tracing the remains of galaxies swallowed long ago. Its shape is not simply a form, it is a record, a living archive of cosmic history written across hundreds of thousands of light years. When astronomers examine Andromeda's spiral arms, they aren't simply admiring their elegance. They are reading them almost the way a scientist studies the layers of an ancient fossil. They track how stars move along those arms, how gas clouds are arranged, how often new stars ignite into existence. Every rotation curve, every clump of dust, every glowing nebula becomes part of a larger investigation into how a spiral galaxy sustains its structure over billions of years. The arms are not decoration, they are physics laid bare, gravity, motion, pressure, and time woven into patterns so large that only patient observation can uncover their meaning. And in those patterns, astronomers find something familiar. Spirals appear everywhere in nature, from the delicate swirl of a seashell to the rotation of a hurricane. The spiral is nature's signature of motion and growth, and in Andromeda, that same signature is written on a stage hundreds of thousands of light years wide. If you imagine drifting closer to Andromeda, moving across the cold emptiness between galaxies, the arms would slowly resolve from a faint blur into vast glowing highways. You would see clusters of bright, newly formed stars gathered like knots of light. You would see great clouds of gas glowing softly, illuminated by ultraviolet radiation from the young stars inside them. Dark ribbons of dust would cut across the light, twisting like cosmic smoke. Some regions would be calm, others turbulent, shaped by winds from massive stars and the remnants of ancient supernovae. Nothing about the arms is uniform. They are textured and alive, filled with movement and transformation. Andromeda's arms also give us something our own galaxy cannot, an external view of a spiral. Living inside the Milky Way means we can never step back far enough to see its full shape. We infer its structure from radio waves, star counts, and motion maps. But Andromeda shows us what a galaxy like ours looks like from the outside. In it, we find a kind of mirror. By studying the placement of its arms, the density of its clusters, the flow of its gas, we learn how to interpret the patterns we detect from our position within the Milky Way. The arms also remind us of the deep timescale galaxies exist on. A spiral galaxy does not rotate like a solid wheel. Its stars move at different speeds depending on their distance from the center. Over billions of years, this differential rotation would twist the arms into tight spirals unless the arms were not made of fixed stars at all, but were patterns moving through the disk. That is why the spiral structure endures even though individual stars drift through it. The pattern lasts even while its ingredients constantly change. It is permanent and temporary, at the same time, a wave moving through a sea of stars. Understanding the shape of Andromeda means recognizing that its structure is inseparable from its scale. When we say Andromeda stretches about 220,000 light years across, we are describing the reach of its spiral arms, their arcs, their outermost curves, the territory they sweep through. Without those arms, the galaxy would be only its central bulge, smaller, less expansive. But with them, the galaxy becomes vast. The spiral pattern is the measurement. It is the architecture that defines the galaxy's true width. And so, by following those arms outward, by tracing their pathways of stars and dust, we move closer to answering our central question. How big is Andromeda really? It is as large as the sweep of its arms, as broad as the waves of matter that pulse outward, as immense as the nurseries of light and shadow that run along those spiraling lanes. The spiral is not just a shape, it is the galaxy's footprint across space, a map of its immensity drawn in arcs of starlight, which naturally leads us toward the next question. What are the stars that fill those arms? How many suns are woven into their structure? And how do we begin the impossible task of counting something so vast that it seems beyond number? When we speak about the immensity of Andromeda, one of the clearest yet most overwhelming measures is simply this: the number of stars it holds. Standing under the night sky, looking up at that delicate blur, it hardly seems believable that inside that faint smudge live hundreds of billions, perhaps even a trillion individual suns. Each one with its own light, its own temperature, its own lifespan. Each one a sphere of fire hanging somewhere across millions of light years of space. We say these numbers casually, billions, trillions, but the human mind is not built to hold magnitudes like that. We can picture a handful of objects. We can picture a room full of people, a stadium full of people. But when the numbers climb into the billions, our imagination starts to slip. And yet astronomers have learned how to estimate what the eye cannot comprehend. No one has ever counted the stars in Andromeda one by one. That would be impossible. Even the most powerful telescopes can only capture a fraction of its population. Instead, astronomers listen to the light itself. Every star contributes a whisper of brightness, and all those whispers add up into the glow we see. By measuring that collective glow and comparing it to models of stellar populations, how bright different kinds of stars are, how common each type tends to be, they can infer how many stars must be present to create the galaxy's overall light. Through this method, Andromeda's star count is estimated at nearly 1 trillion, 1,000 billion suns, more than twice the stellar population of the Milky Way. If you sat down and counted one star per second, no pauses, no sleep, no distractions, it would take you over 30,000 years to reach 1 trillion. And in the time it took you to count them, countless new stars would be born, and countless old ones would fade away. The idea of counting is symbolic. What matters is not the exact total, but the immensity it represents. And yet, within that immensity, the stars are incredibly diverse. Most of them, truly the silent majority, are tiny red dwarfs, cool, dim, and long lived. These small suns burn so gently that they can survive for tens or even hundreds of billions of years. They are almost invisible to the unaided eye, even if you were standing in a nearby star system. But they form the backbone of the galaxy, quiet, steady, persistent. A smaller fraction of stars are more like our sun yellow, balanced and stable over billions of years. These are the stars we think about when we imagine planetary systems like our own. And then scattered like jewels along the spiral arms are the giants. Hot, bright, massive suns that burn fiercely and briefly. Their powerful radiation lights up clouds of gas, carving out glowing nebulae that mark the regions where new stars are forming. They live fast, die young, and when they explode as supernovae, they enrich the galaxy with heavy elements that become the building blocks of new worlds. Astronomers uncover all of this through the spectrum of Andromeda's light. When light is stretched into a rainbow of its component colors, it reveals fingerprints, thin, dark lines corresponding to elements like hydrogen, helium, calcium, iron. These patterns tell scientists what kinds of stars are shining within the galaxy, how hot they are, how old they are, how they are distributed. By comparing these fingerprints to stellar models, astronomers reconstruct the population of stars inside Andromeda, what kinds dominate, which types are rare, how much mass all those stars collectively add up to. And in those details, another truth emerges. A galaxy's star population is a record of its history. The ratio of old stars to young stars tells us how vigorously the galaxy formed stars in its past. The presence of massive blue giants reveals ongoing star formation. The abundance of red dwarfs speaks to the galaxy's long, slow accumulation of stellar generations. So when you look up at Andromeda, you're not simply seeing light. You're seeing the combined glow of 1 trillion histories, 1 trillion individual stories of birth, life, and transformation, all woven together into a single, faint blur in the corner of the night sky. The story of Andromeda's stars is not one of a steady, unchanging rhythm. The galaxy has lived through eras of extraordinary brilliance, epochs when newborn stars ignited in rapid bursts, and quieter stretches when the entire system seemed to drift in a calmer, slower breath. These cycles of activity are preserved in the populations of stars we see today. The youngest stars burn blue, announcing that their birthplaces were active not long ago. The older populations glow warmer, their redder tones marking ancient generations that lived and died long before Earth existed. The mixture of these colors is not random. It is the fingerprint of billions of years of renewal, a record of a galaxy continuously reshaping itself through the lives of its stars. One of the most humbling realizations comes when you remember that each star is not just a point of light, but potentially a full solar system. Many stars host planets. Many planets host moons. Each system is its own tiny universe with its own physics, its own landscapes, its own possibilities. So when we say Andromeda contains roughly a trillion stars, we are also saying it may contain trillions of worlds. Most will be silent, barren, untouched. But even if only a small fraction cradle liquid water, or atmospheres, or geology, the number of potential environments becomes almost impossible to emotionally grasp. The numbers are so large that they stop behaving like numbers at all, and yet everything about them is real, grounded in the light. We measure the models, we test the physics we understand. If you try to picture Andromeda's stars, it may help to begin with something familiar, the night sky here on Earth. On the darkest nights far from city lights, you might see a few thousand stars at most. Through a backyard telescope, that number grows to tens of thousands. And the Milky Way, our own galaxy, seen from the inside, appears as a hazy river of millions of stars blended together. Now take that sense of abundance and expand it, not by a factor of 10 or 100, but by hundreds of billions. That is the scale of Andromeda. Every fleck of light in its disk, every subtle glow in its halo represents another sun. When you look at a photograph of the galaxy and see those shimmering grains, you're seeing only the brightest few. Most of its stars are too dim, too distant, too tightly packed to distinguish individually, even with long exposures. Yet each one contributes to the gravitational harmony that binds the galaxy together. Those stars orbit the galactic center in long, elegant arcs, some sweeping close to the core, others drifting through the outskirts, where the spiral arms thin into darkness. Their combined mass keeps the galaxy stable. Without them, the spiral arms would lose their coherence. The rotation would tear the structure apart. The stars are not decorations, they are the architecture. Among Andromeda's stars are also the remnants of smaller galaxies it has consumed over time. Its extended halo is laced with stellar streams, long ghost-like threads of stars once belonging to dwarf galaxies that wandered too close. Gravity stretched them, shredded them, and folded their stars into Andromeda's vast structure. These are cosmic fossils, pieces of ancient collisions woven into the galaxy's present form. Every one of these stellar rivers contributes to the total star count, adding not only mass, but memory. Andromeda is not static. It is a growing organism shaped by every system it has absorbed. To put this in perspective, Think again of our Milky Way, with its roughly 400 billion stars. That alone is overwhelming, and yet Andromeda surpasses it more than twice as many suns, more stars spanning more space, giving it a deeper gravitational well and a brighter glow. This additional population will matter in the far future. When Andromeda and the Milky Way collide billions of years from now, their stars will mix like currents of light, merging into a new galaxy. Together, these systems will form a single, enormous stellar metropolis containing well over 1.5 trillion stars. Counting stars may sound abstract, but it shapes everything. The star population determines the galaxy's brightness, its total mass, its gravitational pull, and its influence on the smaller galaxies nearby. It informs how Andromeda interacts with the Milky Way, how it grows, how it formed, and how it will evolve. And on a more personal level, the star count defines the scope of possibility for worlds, for moons, for atmospheres, for the faint hope that life may exist elsewhere. When you look up at the night sky and see that soft, unassuming blur, it is easy to miss all of this. It seems so small, so delicate, almost forgettable. And yet, hidden within that delicate glow are 1 trillion suns, each one a universe of its own, each one contributing to the faint stream of ancient light reaching you in a single quiet moment. Knowing this changes the encounter. The blur becomes a city, a galaxy, a vast cosmic archipelago stretching across millions of years and millions of light years, all arriving to your eyes as a whisper in the darkness. When we picture a galaxy, our minds instinctively go to the stars, the glittering points of light, the spiraling arcs, the luminous waves flowing across cosmic darkness. But stars are only the most visible actors in the story. Between them lies something quieter, subtler, and just as essential to the life of a galaxy: the dust and gas drifting in the spaces between. Without this interstellar medium, a galaxy would be nothing more than an aging collection of exhausted suns slowly dimming as their fuel runs out. It would have no way to renew itself, no way to change or grow, no way to form new generations of light. But with dust and gas, galaxies breathe. They inhale, they exhale, they evolve, they give birth to new stars, they reshape their arms, they carry the memory of ancient processes into the future. In Andromeda, this unseen material is gathered most richly in its disk, threaded through the spiral arms like veins of shadow and promise. Dust and gas may sound insubstantial, just wisps, just particles, but they are the reservoirs of everything that comes after. Hydrogen clouds stretch across hundreds of light years, cold and dormant, until something triggers their collapse. When gravity finally overcomes their stillness, stars ignite. Dust grains tiny flecks of carbon, and heavier elements scatter and bend the starlight behind them, carving dark lanes that ripple across Andromeda's arms. To the naked eye, those shadows look like absence, like the galaxy has holes in its light. But the truth is the opposite. Dust is not emptiness. Dust is potential. It is the material from which stars, planets, moons, and atmospheres will one day emerge. Inside the densest clouds, temperatures fall low enough for molecules to form hydrogen, combining into vast molecular clouds the cradles where stellar nurseries begin to glow. Seen through visible light, these nurseries are dark, but shift into infrared and they awaken glowing structures warm with the energy of newborn stars still wrapped in their protective clouds. These regions are the lungs of the galaxy. They are where Andromeda inhales hydrogen and exhales starlight. Gas, too, carries its own story. With radio telescopes tuned to the 21 centimeter emission of neutral hydrogen, astronomers can trace the flow of gas across Andromeda's disk. They can watch how it moves, how it circles the core, how it clumps into spiral waves, how it feeds star formation. These invisible maps often reveal structures that starlight alone never shows arms of gas extending farther than the visible disk rings and ripples shaped by ancient gravitational encounters, echoes of past collisions preserved in the motion of cold hydrogen. The dust also speaks. It absorbs light, unevenly dimming some regions more than others. That effect, called extinction, changes the colors we see. By measuring it, astronomers reconstruct how much dust is present, where it lies, and how it shapes the galaxy's appearance. Infrared observatories like Spitzer and Herschel have shown that Andromeda is wrapped in intricate arcs and rings of dust, a pattern that may be the fingerprint of past interactions with smaller galaxies passing too close, compressing gas into new formations. Without dust and gas, Andromeda would already be fading. Stars would age, collapse, and leave only remnants behind. But because gas continues to collapse into new suns and stars, continue to forge heavy elements in their cores before spreading them into space through winds and supernova explosions. The galaxy remains a living system, one generation enriching the next. The heavy elements in Andromeda's dust grains, carbon, oxygen, silicon, iron, were created in earlier stars scattered by stellar death, gathered again, into clouds. They are the ingredients that seed planets, the materials that form rocks and soils and atmospheres, the chemistry that makes complex molecules possible. So, when we talk about the immensity of Andromeda, we often point to its star count, its halo, its diameter, but its immensity isn't only in its size. It is also in this ongoing cycle of renewal, in the way the galaxy breathes through dust and gas, in the way it transforms darkness into starlight, in the way it carries the memory of ancient stars into future generations. Andromeda is not a finished object. It is a process, slow, patient, alive. This dynamic, the Quixote choreography between dust gas and starlight, is what makes spiral galaxies like Andromeda so mesmerizing. The bright clusters and dark lanes are not merely beautiful patterns, they are the visible fingerprints of deep cosmic processes. They are the living evidence that a galaxy is not just glowing in the night, but actively sustaining itself, renewing itself, remembering its past, and quietly shaping its future. Even here on Earth, we feel the influence of dust and gas in our own Milky Way. The dark bands that cut across the Milky Way's bright river are formed by dust drifting between us and distant stars. Those clouds hide entire regions from our view. They block our sight lines and make some parts of the sky opaque. Without that dust, the sky would be clearer, But the galaxy would also be emptier, less fertile, stripped of the raw material needed to form new suns. It is a trade off. Every galaxy accepts obscurity in exchange for renewal. Astronomers have learned to navigate this veil by using other wavelengths of light. Infrared pierces through dust. Radio waves map gas. Ultraviolet reveals the glow of newborn stars. In Andromeda, dust blocks what our eyes can see, yet illuminates what our instruments can detect. It hides the stars behind it, but in infrared it draws delicate outlines of structures, otherwise invisible arches, rings, ripples, signatures of events written into the galaxy's deep memory. And the scale of these clouds is astonishing. Some stretch across dozens, even hundreds of light years, vast reservoirs containing enough material to form thousands of stars. Inside them, small pockets collapse first. Clusters ignite. The rest of the cloud may linger for millions of years before dispersing into the surrounding disk. Each cloud participates in this grand motion, drifting through the spiral arms, tugged by gravity, sculpted by density, waves jolted by the shock fronts of previous supernova. It is a shifting landscape, turbulent, chaotic, yet structured enough to maintain a steady rhythm of creation. Andromeda's dust isn't arranged the way dust appears in many other galaxies. Instead of smooth, consistent spirals, its dust forms a series of concentric rings patterns, like ripples frozen in the act of spreading outward. These rings are likely the aftermath of an ancient collision with a smaller galaxy, an encounter that disturbed Andromeda's disk, sending waves of compressed gas radiating outward and triggering bursts of star formation. A galaxy carries its history not in words, but in shapes. To study Andromeda's dust and gas is to read that history, to see the scars of encounters, the remnants of mergers, the echoes of past interactions imprinted in the very structure of the galaxy. Dust and gas tell us not only what Andromeda is now, but what it has endured. This interplay stars collapsing stars, forming dust, gathering dust, dispersing, is why galaxies can live for billions of years. When stars age, they return material to the interstellar medium through winds and supernova explosions. That material, enriched with heavier elements, forged in stellar cores, mixes into the dust and gas. New stars form from that enriched material. Around those stars, planets take shape. Around those planets, atmospheres develop, and the cycle continues. A galaxy is not a fixed object, it is a self sustaining ecosystem. Calling this process a breath is not just poetic, it accurately reflects the rhythm. Andromeda inhales gas into dense clouds. Those clouds collapse into stars. Then the galaxy exhales enriched material back out into space. The cycle unfolds slowly, millions of years per breath, but the pulse is there steady and ancient, shaping the galaxy across cosmic time. This breath defines Andromeda's appearance and its future. Its bright arms glow because dust and gas are present. Its structure is sculpted according to where matter gathers, where it collapses, where it is swept away by radiation and stellar winds. And its fate, how long it continues forming new stars, depends on how much gas remains, how much potential still lies in the cold, drifting medium between the stars. Far in the future, Andromeda may exhaust its reserves. It may become a quieter, dimmer galaxy, one where new stars are rare. But for now, it is still alive, breathing, renewing, reshaping itself through the interplay of darkness and light. When we ask how big Andromeda truly is, we have to include this hidden substance, the dust, the gas, the invisible scaffolding that extends beyond the visible disk. They add mass, they shape the light, they influence the gravity, they define the galaxy's capacity to evolve. The immensity of Andromeda isn't just in its size or its stars. It is in the medium that fills it, the quiet material that makes galaxies into living systems rather than static islands of aging suns. And at the very center of Andromeda, deeper than the spiral arms, deeper than the rings of dust, deeper even than the dense swarm of stars clustering in its core, lies something neither dust, nor gas, nor starlight can reveal. Something invisible yet undeniable. Something so gravitationally fierce that nothing, not even light, can escape its pull. A presence we cannot see, but one that shapes the entire galaxy around it. Revealed only through the way the space around it behaves, this hidden presence at the very core of Andromeda is something both profound and unsettling. It is the supermassive black hole at the galaxy's center, an object so compact and so heavy that its gravity governs the entire inner region like an invisible conductor guiding a cosmic orchestra. When people hear the term black hole, they often imagine a bottomless drain pulling in anything that strays too near. But the reality is far more nuanced. A black hole, even one of extraordinary size, is not so much an emptiness as it is a place where matter has collapsed to a point so dense that the familiar rules of physics begin to fold in on themselves. At the heart of this region lies a singularity wrapped by the event horizon, a boundary beyond which nothing, not even light, can escape. Matter that falls toward this boundary is stretched, heated, and twisted into extreme states. The black hole itself emits no light, yet the space around it can blaze brilliantly as gas spirals inward, glowing from friction and gravitational stress. In Andromeda, this central black hole is truly enormous. Its mass is estimated to be around 100 million times that of our Sun. When you compare that to the black hole at the center of our own Milky Way, which is roughly 4 million solar masses, the difference is astonishing. Andromeda's central object is not just larger, it is one of the most massive black holes known among galaxies similar to ours. That incredible weight extends its influence outward, shaping the orbits of stars in the bulge and setting the tone for the galaxy's inner motion. Astronomers infer its existence not by seeing it directly, but by watching how stars behave around it. Near the core of Andromeda, stars whip around at tremendous speeds, following paths that only make sense if something extraordinarily massive is pulling on them. By mapping these stellar motions, scientists reveal the presence of that hidden central mass. Over and over, the data point to the same conclusion: a supermassive black hole, dark yet inescapably real. Some of the fastest stars in Andromeda trace tight loops close to this central region. Their motion becomes a measuring tool, allowing astronomers to refine their estimate of the black hole's mass. And despite its size, Andromeda's black hole is surprisingly subdued. In some galaxies, central black holes feed aggressively on nearby matter, shining as brilliant beacons known as quasars or active galactic nuclei objects so luminous they can outshine entire galaxies. By contrast, Andromeda's central giant is quiet. It consumes little radiates gently and slumbers rather than roars. This quietness is a blessing for galaxies in the local group. A more active black hole would unleash torrents of high energy radiation across vast distances. Instead, the core of Andromeda sits in relative calm, an immense gravitational anchor content to hold space together without sending violent outbursts across the cosmos. Its enormous mass raises deep questions about its past. Did it begin small and grow over billions of years by slowly accreting gas? Or did it swell rapidly in the early universe as multiple black holes merged into one? The size of Andromeda's central black hole hints at a long history of growth. And because Andromeda has swallowed smaller galaxies throughout its life, their central black holes may have drifted inward and fused with the larger one. Each merger would have unleashed gravitational waves, reshaped the galaxy's core, and added yet another layer to Andromeda's history. What makes this object even more remarkable is not just its mass, but its role as an essential part of the galaxy's architecture. It is not a separate phenomenon tucked in the center. It is intrinsic to how the entire system operates. The bulge rotates around its gravity. Gas flows respond to its pull. Even the geometry of the inner region is sculpted by this unseen weight. Without it, the heart of Andromeda would move differently. With it, the galaxy has an anchor, silent, invisible, yet commanding. If you could drift close to this region, an impossible journey, but imagine it anyway, you would find yourself in a domain where the familiar concept of gravity dissolves into something far stranger. Light curves around invisible contours. Time itself stretches. Gas falling inward heats to millions of degrees, glowing in X rays. Magnetic fields twist into complex knots. Space bends. And if you orbited just outside the event horizon, your experience of time would slow dramatically. From your perspective, the rest of the galaxy would seem to accelerate into the future while you lingered. This is not fantasy. It is a direct prediction of general relativity, the framework that describes how mass and energy distort space and time. Though no telescope can see the black hole itself, its presence can be felt in the high energy light it affects. Sensitive instruments detect faint X ray emissions from the hot gas near the core. Subtle variations in this radiation whisper the signature of the gravitational giant hiding there. And so, in a galaxy full of starlight, hundreds of billions of suns scattered across a disk, hundreds of thousands of light years wide, the darkest object of all sits at the center, quiet and unlit, yet shaping everything around it. A region where gravity becomes so intense that it rewrites the rules, a place where time bends and matter falls inward, and the heart of Andromeda continues its slow, steady pulse. Observations made with sensitive X ray telescopes have picked up a faint glow from superheated gas swirling near Andromeda's central abyss. The light is subtle, far dimmer than the storms around active galactic nuclei, but unmistakably tied to the intense gravity near the event horizon. That soft whisper of radiation is one of the clearest confirmations that a massive black hole is truly there, shaping the matter that drifts too close. In the years ahead, new instruments may sharpen that view even more. Technologies like the Event Horizon Telescope, which captured the silhouette of the black hole in Galaxy M87, might one day be refined enough to glimpse Andromeda's core directly. For now, though, we understand it mostly through its influence. Through the stars, it commands the gas. It disturbs the motions it sculpts at the heart of the galaxy. And that influence doesn't stop with Andromeda itself. Its black hole plays a role in the galaxy's future, too. Billions of years from today, when Andromeda and the Milky Way drift into each other's embrace, their central black holes will gradually spiral inward. In time, the two will merge, forming a single, even greater black hole, weighing hundreds of millions of solar masses. That moment will send gravitational waves, ripples, in the fabric of space-time outward across the cosmos. Humanity will be long gone by then, but the prediction is as firm as any we can make. These black holes are not merely silent anchors. They are long-term participants in cosmic events playing out over almost unimaginable timescales. It's humbling to realize that the faint blur visible from Earth contains something so extreme, an object 100 million times the mass of the Sun, hiding in plain sight. A creature of gravity so powerful it shapes the motions of billions of stars, yet so quiet we can barely detect its presence. It reminds us that galaxies are more than bright spirals and glowing clusters. They harbor mysteries at their cores, places where the rules of physics fold and twist in ways we scarcely understand. But the black hole doesn't sit alone. Surrounding it is a crowded population of stars moving at tremendous speeds. These stars weave complex orbits, interacting gravitationally in a chaotic dance. Some will eventually be pulled too close and vanish forever behind the event horizon. Others will be flung outward, accelerated to extraordinary velocities that send them racing across the galaxy. Even though the black hole itself is calm, the region around it is full of motion, full of energy, full of change. To appreciate Andromeda, we must include this hidden heart in the picture. The galaxy's size is not just its spiraling disk or its glowing arms. It is also this single compact point of almost unimaginable density. Without the black hole, the motions of the central bulge would not make sense. With it, the entire structure gains coherence, as though an unseen weight at the center keeps the galaxy balanced. The immensity of Andromeda is written not only across hundreds of thousands of light years, but also at the singularity where scale loses meaning. And even beyond the core, Andromeda is not alone in the darkness. Like the Milky Way with its Magellanic clouds, Andromeda carries a retinue of smaller galaxies. They orbit quietly in its gravitational field, forming a larger system, a family bound together over millions of years. To understand the full size of Andromeda, we must consider the company it keeps. The most prominent of these companions are M32 and M110. M32 is unusually compact, its stars packed tightly into a bright concentrated knot. Many astronomers believe it may once have been much larger, stripped down to its dense core by Andromeda's relentless gravity. M110, by contrast, is more diffuse. Its light is softer, spread across a wider region, and faint trails of stars hint at past interactions that reshaped it over time. Both galaxies orbit close to Andromeda's disk, and even small backyard telescopes can reveal them as soft glows beside the main spiral. Beyond these lie dozens of dwarf galaxies, tiny companions barely visible against the backdrop of space. Many were only discovered recently by deep sky surveys that detected slight enhancements in star density. Some are irregular, little more than scattered clusters with no obvious symmetry. Others are smooth, spheroidal dwarfs, dim and ghost like. Each contains a few million or tens of millions of stars, tiny compared to Andromeda's trillion, but still cosmically significant. Their relationship with Andromeda is dynamic. Gravity constantly stretches and tugs at them. Some companions are in the process of being torn apart entirely. Their stars stream out into long, delicate arcs that wrap around the main galaxy like pale ribbons. Deep images reveal these stellar streams, clearly silent evidence of past encounters where Andromeda consumed the galaxies around it. These remnants become part of Andromeda's halo, gradually blending into the larger whole. And so, when we speak of Andromeda's true extent, we cannot limit ourselves to its central glow or even its spiral arms. Its size includes the satellites it shepherds, the streams of stars it has absorbed, and the halo that stretches far beyond the visible disk. In this wider view, Andromeda is not just a single galaxy. It is the center of a vast, evolving community, a structure shaped by time, by gravity, and by the quiet pull of its enormous heart. This process is still unfolding even now. Some of Andromeda's companions are in the middle of being stripped apart, their stars stretched thin and slowly folded into Andromeda's enormous halo. The galaxy is digesting them the way it has done for billions of years. This isn't unique to Andromeda. Our Milky Way does the same. At this moment, the Sagittarius dwarf galaxy is being unraveled and spun into long looping streams that wrap around our own galactic disk like faint threads of light. The difference is scale. Because Andromeda is larger and more massive, its gravitational grip reaches farther, its influence runs deeper, and the number of satellites it has consumed over cosmic history may be far greater. The faint arcs and ghost like shells of stars surrounding it are the remnants of those encounters, a fossil record of galaxies long since absorbed. Studying these satellites matters because they reveal the environment Andromeda lives in. Their number, their arrangement, their individual histories all become clues about how dark matter shapes galaxy formation. According to cosmological models, a large galaxy should be surrounded by many smaller ones, each wrapped in its own miniature dark matter halo. The dozens of companions around both Andromeda and the Milky Way support this idea, though astronomers still debate whether there are fewer dwarfs than the models predict. Every new discovery, especially the ultra-faint satellites that barely stand out from the background, adds another data point, helping refine our picture of how galaxies assemble themselves over time. All of this changes the way we interpret Andromeda's true size. Its disk may span roughly 220,000 light years, but the galaxy's actual domain is far larger. Its gravitational influence stretches across millions of light years, binding not just its own stars, but the stars of many surrounding galaxies. To say Andromeda is immense means including this entire extended system, not just the bright spiral we picture in our minds. Each tiny companion is a part of that immensity, another piece of a structure far grander than the glowing disk alone. There is a story hidden in the differences among these satellites, too. Some are still forming stars rich in gas. Others are silent and exhausted, made of nothing but old dim suns. That contrast often comes down to distance, how near they pass to Andromeda's deep gravitational well. Those that venture close tend to have their gas stripped away, their star forming material lost to tides or to the pressure of Andromeda's surrounding halo. Without gas, they can no longer produce new stars and slowly fade into quiescent relics. Satellites that remain farther out can keep their gas and continue forming stars for longer. In this way, Andromeda is not just a backdrop. It actively reshapes the evolution of the galaxies around it, deciding which ones remain vibrant and which ones go quiet. Some of the faintest companions are so diffuse that even powerful telescopes struggle to detect them. They look like tiny gatherings of stars, barely brighter than the night sky itself, requiring precise surveys and careful analysis to tease them from the background. The discovery of these ultra faint dwarfs has broadened our understanding of how complicated a galactic ecosystem can be. Andromeda's family is larger, more varied, and far more delicate than astronomers once believed, a reminder that galaxies are not isolated structures, but communities. These satellites, in turn, influence Andromeda. As they orbit, they shed stars and dark matter into its halo. Their gravitational pull can disturb the spiral arms, creating ripples, rings, or subtle warps in the disk. With every encounter, however small, Andromeda is reshaped. It is not a static object frozen in time, but a changing system continually molded by the companions that move around it. If you could drift outward from Andromeda, leaving behind the glowing core and the wide spiral arms, you would start to encounter these satellites scattered through space. Some would appear as bright, compact knots. Others would look like dim, irregular smudges. Others still would be almost invisible, a handful of ancient stars drifting together in the dark. Each one would have its own origin story, its own trajectory, its own interaction, history. Yet all of them would be bound by Andromeda's gravity, tied to the same cosmic anchor. The galaxy's true size includes all of them. It is not just a disk, it is a sprawling system of dozens of galaxies moving in a shared gravitational dance. Thinking about these companions also puts scale into perspective. A dwarf galaxy with a few million stars would be enormous compared to anything in the human world, a structure so vast it defies intuition. Yet beside Andromeda, such a galaxy becomes almost insignificant, a soft whisper orbiting a giant. The contrast is stark. Andromeda is the dominant mass, the central presence, while its satellites are quiet sparks circling its gravity. And still, without them, the full picture would not be complete. They reveal Andromeda's reach, its history, and its role in the broader architecture of our cosmic neighborhood. To study Andromeda properly is to study all of this: the main galaxy, its companions, the streams of stars stretching around it, the dark matter that binds everything together. It is not a single object, but a network, a family of galaxies interacting over immense spans of time. These satellites help us understand how Andromeda grows, how it shapes the space around it, and how it fits into the structure of the local group. They show us that even on a galactic scale, relationships matter. Andromeda's immensity is not just the width of its disk, it is the full reach of its gravitational family, the entire domain of space it commands, and the countless smaller galaxies that revolve within its influence. Every time you lift your gaze toward the night sky, what reaches you is not the universe as it is in this moment, but the universe as it once was. Light is fast, but not infinitely fast. It needs time to move across the silent distances of space. Because of that, everything we see is shifted backward into earlier chapters of cosmic history. For nearby objects, that backward shift is tiny. Moonlight is only a little over a second old. Sunlight is barely 8 minutes old. But with Andromeda, the scale becomes something else entirely. The light that forms that delicate smudge overhead began its journey more than 2 million years ago. You are not seeing Andromeda tonight. You are seeing the version of it that existed long before human civilizations appeared. To realize this is to understand that vision itself is a form of gentle time travel. The photons now entering your eyes were released when early humans were shaping the first stone tools, when ice blanketed continents, when Earth was inhabited by creatures we would hardly recognize. Those photons have been drifting toward us across intergalactic darkness ever since, carrying the imprint of an ancient moment. Every glance at Andromeda is a direct link to that distant past. In astronomy, this delay isn't unusual, it is the rule. Everything we observe is a memory. Every star, every nebula, every galaxy is an echo of what once was. But Andromeda sits at a scale that makes the delay strangely intimate, vast enough to be awe-inspiring, yet close enough to feel like a bridge between our world and a chapter of prehistory that still belongs to the story of our species. Galaxies millions of light years beyond it show us eras billions of years old. Andromeda carries an ancient message, but one that still sits near the edges of human origin. The light that reaches us from Andromeda is not from one source, but from billions. Each star contributes its own faint signal. Some of those stars no longer exist. They may have collapsed, merged, or exploded long before their final light finished its journey toward us. Others have shifted in brightness or evolved into new stages of life. Yet what we receive is the preserved record of how they looked 2.5 million years ago. When you see the galaxy, you are reading a cosmic fossil, a frozen portrait from deep time. Astronomers rely on this property of light not just to admire the universe, but to study its history. The farther they look, the older the universe becomes. The most remote galaxies we detect show us the cosmos as it was only a few 100 million years after the Big Bang. In that context, Andromeda is one of the closer pages in the cosmic archive, still ancient, but not unreachable. There's a quiet humility in knowing that the Andromeda we witness now may already be different. Star clusters may have drifted, nebulae may have ignited new generations of stars. A supernova may have erupted somewhere in its arms, but we will not see those changes until long after our entire civilization has risen and faded. As observers, we are always looking backward, always reading chapters long since completed. This isn't a flaw or a limitation. It is the natural flow of the universe, and the story becomes even richer when we consider that the light is not uniform. Different wavelengths carry different layers of Andromeda's history. Visible light reveals the stars and the overall shape of the spiral. Infrared slides past the dust and shows us hidden structures, cold clouds, and star-forming nurseries. Ultraviolet traces the youngest and hottest stars, and X-rays expose the violent energetic environments near supernova remnants and the region around the central black hole. Each wavelength arrives at the same time, but each reveals a different piece of the galaxy's long journey. When all of this light combines in your vision, it becomes something simple, a faint blur in the night. But beneath that simplicity lies a profound truth. What you are seeing is 2 million years old. The present day Andromeda exists beyond that horizon of time, invisible to us for now. What we see is the version that the universe has allowed us to glimpse, a memory carried across a gulf of darkness, still traveling, still whispering a story older than humanity. Together, all of these wavelengths weave themselves into a single composite portrait, a layered record far richer than anything the human eye could capture on its own. To us, Andromeda appears soft and pale, almost like a ghost drifting at the edge of vision. It takes effort to notice it at all. But to a telescope especially, one capable of gathering light over long, patient exposures, that same faint glow becomes something vibrant and unmistakably alive. A telescope can receive photon after photon, collecting them slowly, quietly, over minutes or hours. What the eye loses, the instrument gathers. And in that gathering, Andromeda reveals its true structure, the sweep of its spiral arms, the sharpness of its dust lanes, the clusters of stars scattered across its disk. The light has always been arriving here, falling onto Earth silently. Our tools simply allow us to grasp more of it, to let enough of that ancient radiance accumulate, that the galaxy's hidden details emerge. It's astonishing to realize that every image of Andromeda, every glowing arm, every delicate thread of dust is made of photons that began their journey millions of years ago. Each pixel in those pictures is a fragment of ancient history delivered to us across intergalactic space. Each color and contour is a message preserved in its long travel. Andromeda is unimaginably far away, yet its light is here with us, arriving right now, entering our instruments and our eyes. We do not need to cross the universe to encounter it. The universe brings its light to us night after night in a steady stream that began long before our species existed and will continue long after we are gone. Understanding light through time means understanding the deep connection between distance and history. When we look at Andromeda, we are not looking at a static picture. We are witnessing a moment in its long unfolding life. 2.5 million years feels like an eternity to humans, yet for a galaxy it is barely a breath. Andromeda existed for billions of years before this light began its journey, and it will exist for billions of years thus after. What reaches us tonight is one frame in an unimaginably long cosmic film. The immensity of the galaxy is not only in how wide it spans across space, but in how deeply its history stretches across time. And the light never stops. Tonight, new waves of photons arrive. Tomorrow, more will follow. Each stream carries a slightly different fragment of the galaxy's past. When you stand beneath a dark sky and gaze upward, you are letting this ancient light wash over you, becoming for a moment part of a river that has been flowing since before human memory. There's also something beautifully personal in this. The photons that enter your eyes end their journey with you. No one else will ever receive those exact photons again. Their long voyage across the void ends the moment they meet your vision. In that sense, the connection between you and Andromeda is direct, intimate, and unique. A galaxy of 1 trillion stars can still create a one-to-one moment, one photon, one observer, one meeting after millions of years in flight. That intimacy doesn't diminish the galaxy's immensity. It deepens it. It shows how something so vast can still whisper directly to an individual consciousness. So, when we speak about the size of Andromeda, we must include this temporal dimension. Its immensity is not only measured in kilometers or light years, but also in the depth of the time its light carries. To see it is to see both distance and duration, vastness and connection, enormity and personal meaning. And that brings us to a deeper question. What does it mean for humans to exist in the presence of such scales? How do we measure ourselves against something so large, so old, so far beyond the range of our senses? We spend our lives on a planet that already feels immense, a world that stretches beyond our daily reach, surrounded by oceans that take days to cross and continents that take hours to fly over. Our solar system is even larger, with distances so great that spacecraft require years to travel between planets. Light from the sun takes 8 minutes to reach us, and even that feels like a vast separation. But set all of that next to the 2.5 million light year gulf between us and Andromeda, and everything we know collapses into a scale too small to register. The Earth becomes a tiny speck. The solar system becomes a pinprick. Our entire civilization becomes a momentary flicker, invisible against galactic distances. It's easy at first to interpret that contrast as insignificance, to imagine that if galaxies are so vast, then human lives must somehow matter less. But that interpretation misses something essential. Smallness is not the same as meaninglessness. Human scale is not meant to rival galactic scale. It exists alongside it. The fact that we can perceive Andromeda at all, the fact that we can measure it, question it, imagine it, the fact that we can send thoughts and instruments into the cosmos to explore it is extraordinary. In a universe so enormous that galaxies are separated by millions of light years, consciousness has arisen on a small blue world capable of understanding those distances. That capacity does not shrink us. It places us. It gives us context, relationship, perspective. The galaxy's size does not erase our significance. It reveals it in a different dimension. Because Andromeda is immense, and we are aware of that immensity. And that awareness is its own kind of greatness. We never judge the worth of a flower by comparing its petals to the height of a mountain, and we never measure the significance of a thought by weighing it against the mass of a planet. Human meaning unfolds on a different scale, one not tied to size or duration, but to perception, awareness, and the quiet depth of experience. Our existence is rooted in a scale that galaxies do not occupy the scale of consciousness, of noticing, of wondering. And it is this scale that allows us to stretch our minds across distances that would otherwise seem unreachable. We can contemplate 1 trillion stars without ever touching one. We can imagine millions of light years without crossing them. We can build instruments that gather the faint breath of Andromeda and translate it into images, into measurements, into understanding. No other known creature carries that capacity. Andromeda may hold 1 trillion suns, but only consciousness can give those suns meaning. In that sense, the vastness of the galaxy is mirrored by the vastness of the mind that perceives it. It also helps to remember that the material of our bodies, carbon, oxygen, iron, calcium, was forged inside ancient stars. We are literally made of the same substance as galaxies. The immensity is not just around us, it lives within us. Every atom in our bones is part of a lineage that stretches back to supernovae and stellar furnaces. The human scale and the galactic scale are not competitors. They are two expressions of the same cosmic story. Our own measure of time fits inside the longer rhythms of the universe. We live decades. Civilizations rise and fall over centuries. Meanwhile, Andromeda's light takes millions of years to reach us. Its stars live billions of years. Its central black hole has existed for more than 10 billion years, and yet our short lives still belong to the same timeline. We are not erased by the immensity we are located within it. Our moments are notes in a symphony that began long before us and will continue long after. When we try to picture 1 trillion stars, the mind strains. But when we reflect on our own sun, the warmth it gives, the life it sustains, the abstraction softens. We extend that familiarity to other stars, imagining countless worlds, countless possibilities. The vastness becomes a landscape for imagination, curiosity, and wonder, and in this way, the human scale becomes the very means by which cosmic scale becomes meaningful at all. Stand beneath a dark sky and look toward Andromeda. In that moment, Scales converge. A body a few meters tall, standing on a planet only 12,000 kilometers across, orbiting a star in a galaxy of hundreds of billions of stars, looking at another galaxy with nearly a trillion. The contrast is overwhelming, and yet it is exactly in that contrast that the encounter becomes profound. The human scale becomes aware of the galactic scale, and the galactic scale becomes visible to a human mind. That meeting is one of the deepest experiences available to us. For thousands of years, humans have felt this mixture of awe and humility. Philosophers called it the sublime. Poets tried to describe it. Ancient stargazers felt it when they saw the Milky Way arcing overhead, or when they noticed the faint smudge of Andromeda without knowing what it truly was. The sky has not changed, only our understanding has deepened. Recognizing the difference in scales isn't merely philosophical, it's practical. When we place ourselves against galaxies, we see how fragile our world really is. Earth is a thin shell of habitability surrounded by an indifferent cosmos. Galaxies will continue for billions of years long after our sun fades. Our survival depends on how we care for the thin envelope of life we've been given. The vastness doesn't make our choices smaller, it makes them more precious. Thinking on these scales also transforms the future of the Milky Way and Andromeda into a human story. Their collision in 4 billion years is a simple gravitational inevitability from the galaxy's perspective. But from ours, it becomes a narrative, an event in the deep future that some distant descendants, perhaps not even human in form, may witness. The merger will brighten the sky with rivers of stars, reshape the night into something unrecognizable, and eventually produce a new galaxy altogether. The galaxies themselves do not tell stories, but we do, and that is the heart of it. Placing ourselves against the vastness is not about comparing sizes or lifespans. It is about recognizing the relationship. The universe expresses itself as galaxies, students planets, and also as minds capable of understanding galaxies, stars, and planets. The immensity is not only out there, part of it is in here, in awareness, in perception, in the ability to look up to wonder, to ask what it all means. Galaxies may stretch across hundreds of thousands of light years, but the human mind can still reach toward them. Our bodies may be small, but they are assembled from the same ancient atoms that once burned inside long dead stars. Our lives may be brief, but they unfold inside a universe that continues long after our hours end. The scale of a galaxy and the scale of a human life are not opposites. They are two different ways the universe expresses itself. And as we keep drifting deeper into the story of Andromeda, we carry this double awareness with us. We are small, but we are not insignificant. We are temporary, but not without meaning. Our value doesn't come from being at the center of the galaxy. It comes from being conscious within it, from being able to look upward and ask what any of this truly is. That act of wondering, of reaching beyond our size and our years, is its own kind of scale, a scale that stretches outward toward the very immensity we contemplate. Long before telescopes, long before anyone imagined galaxies as separate islands of stars, people noticed a pale mark in the constellation we now call Andromeda. They didn't know what it was. They didn't have language for galaxies or spirals or trillions of suns. But they saw something. They recorded it. They wove it into their sky maps. The story of Andromeda is not just a scientific story, it is a cultural one, a human inheritance passed from one generation of skywatchers to the next. The earliest surviving written reference comes from the Persian astronomer Abd al-Rahman al-Sufi in the 10th century. In his Book of Fixed Stars, completed in the year 964, he described a little cloud, a dim patch tucked into the pattern of Andromeda. His account wasn't the first time anyone noticed it. People had surely seen it for thousands of years, but it is the first written description that still exists. His record preserved the blur so future generations could rediscover it. The Greeks mapped the constellation of Andromeda long before Al-Sufi, tying it to their myths of a princess chained to a rock rescued by Perseus. The stars forming her outline were clear, bright, easy to see. The faint glow of the galaxy lies inside that same pattern. No surviving Greek text explicitly mentions it, but under truly dark skies, careful observers could have spotted it. Its faintness makes it easy to overlook, but not invisible. Other sky-watching traditions likely noticed it as well. Indigenous cultures around the world have rich cosmologies describing rivers of stars, celestial animals, pathways across the night. Even if their knowledge did not survive in the written form that reached us, it's hard to imagine that a visible patch of light remained entirely unseen throughout the ancient world. By the Middle Ages, Andromeda's blur traveled into European astronomy through Arabic scholarship. Al-Sufi's work influenced Islamic astronomers who influenced European scholars, and the little cloud entered medieval star catalogues as one more mysterious nebula. In that era, the term nebula simply meant cloud, any faint, fuzzy object whose nature was unclear. Andromeda stayed in that category for centuries, known but unexplained. Everything changed when the telescope arrived in the early 1600s. Lenses and mirrors opened the sky, magnifying faint patches into clearer shapes. In 1612, the German astronomer Simon Marius described the Andromeda Nebula through a telescope, noting its brighter, more extended glow. Galileo may have glimpsed it as well, though no record confirms it. Even then, no one understood what they were seeing. Andromeda remained a nebula, thought to be a cloud inside the Milky Way. As astronomy advanced, Andromeda's place in catalogues solidified. Charles Messier added it to his list of objects that were not comets, faint blurs that could confuse a comet hunter. His catalog entry designated it Messier 31, or simply M31, a name that endures today, printed in star maps and astrophysics papers alike. For all that time, Andromeda remained mysterious, familiar, yet unknown, observed yet misunderstood. William Herschel, the same observer who discovered Uranus, also turned his attention to the soft glow in Andromeda. Through his early telescopes, he saw a bright central region fading into a wide misty haze, and he noted its unusual shape. Even then, some astronomers quietly wondered whether these hazy spirals scattered across the sky might be entire systems of stars. But at the time, that idea was almost too bold to accept. The dominant belief was that the Milky Way was the universe, and everything we saw, every nebula, every patch belonged inside it. That uncertainty carried into the early 20th century until a debate began simmering among astronomers. Heber Curtis argued that spiral nebulae were island universes, galaxies in their own right, unimaginably far beyond the Milky Way. Harlow Shapley disagreed, insisting that our galaxy encompassed the whole cosmos. Their disagreement became the centerpiece of what we now call the Great Debate of 1920, held at the Smithsonian in Washington, D.C. And at the heart of that debate was a simple question with enormous consequences. What is Andromeda, a cloud inside our galaxy, or a galaxy of its own? It took only a few more years for the answer to arrive, carried by the quiet precision of Edwin Hubble. Using the 100-inch Hooker telescope on Mount Wilson, the largest telescope in the world, at the time Hubble identified Cepheid, variable stars within Andromeda. By measuring the rhythmic brightening and dimming of these stars, he determined their true brightness and therefore their distance. They were far too distant to belong to the Milky Way. That single discovery blew open the boundaries of the universe. Andromeda wasn't a cloud inside our galaxy, it was a galaxy beside ours. The universe instantly expanded from one system to many, and humanity's place within it shifted forever. Looking back, it's astonishing how long Andromeda lived in our collective imagination as nothing more than a faint smudge noticed by Al-Sufi in the 900s, catalogued for centuries, yet misunderstood until barely 100 years ago. The galaxy didn't change. We changed. Our tools sharpened. Our questions deepened. Our willingness to challenge comfortable assumptions grew. Even the names we've given Andromeda reflect that evolution, from Little Cloud to Andromeda Nebula to Messier 31, and finally to Andromeda Galaxy. Each name marks a different era in our understanding, and what's remarkable is that humanity never lost sight of it. Across thousands of years, observers under dark skies kept noticing the same faint glow and preserving it in their stories and maps. Because of that unbroken chain of attention, Hubble knew where to point his telescope when the time came. The blur in the constellation of a chained princess became the key to revealing a universe filled with galaxies. When we look at Andromeda today, we're not just looking outward at a galaxy, we're looking backward into the history of human curiosity. Seeing it with your own eyes places you inside that multi-millennia lineage of people who looked up and wondered at the same shimmer. Under a truly dark sky far from any city, Andromeda still appears exactly as it did to ancient stargazers, a faint smear of light hovering at the edge of vision. But the telescopes that followed changed everything. That blur became a sweeping spiral of stars, dust, and gas, a living system full of structure and motion. When Edwin Hubble first resolved individual stars in Andromeda nearly a century ago, it was revolutionary. But the tools that came afterward have taken us far beyond what he could have imagined. The Hubble Space Telescope, launched in 1990, produced the most detailed images of Andromeda ever recorded. Its cameras resolved millions of stars, something no ground based telescope could match with such clarity. In 2015, a massive Hubble mosaic stunned the world, a 1.5 billion pixel portrait of Andromeda, each tiny point a star. It remains one of the largest astronomical images ever assembled and gave humanity a visceral sense of the galaxy's true richness. But visible light is only part of the story. Infrared observatories like Spitzer and Herschel revealed the galaxy's structure hidden beneath the dust rings, ripples and arcs carved into its disk, each one a silent record of past encounters with smaller companions. These structures don't appear in visible light. Our eyes cannot see them. But in infrared, the galaxy glows with warm patterns that reveal its deeper history, including waves of star formation triggered long ago by gravitational interactions. In ultraviolet light, the Galaxy Evolution Explorer Galax offered a completely different vision of Andromeda. Suddenly, regions that look quiet in visible light revealed themselves as bright islands of young hot stars. These ultraviolet signatures trace places where gas has recently collapsed under gravity, where the galaxy is actively building new clusters. UV light doesn't travel easily through dust, so what Galax captured were the exposed energetic pockets of renewal fresh stars still glowing with their first heat. Placed alongside infrared images, the contrast is striking. Infrared shows you the ingredients, the dust, the cool gas, the raw material waiting to ignite. Ultraviolet shows you the outcome, newborn stars lighting up their surroundings. Together, the two wavelengths form a kind of before and after portrait of stellar birth. One reveals the cradle, the other reveals the child. And between them is the story of a galaxy constantly cycling through creation and dissolution. X-ray observatories like Chandra and XMM Newton add another layer entirely. In these high-energy views, Andromeda becomes a landscape of violence. Supernova remnants glow as expanding shells of gas heated to millions of degrees. Binary star systems flare, where material from one star spirals onto a dense companion, releasing bursts of X-ray light. Even the quiet-looking central black hole reveals itself through faint emissions. Small flickers of radiation from matter heated as it nears the point of no return. These X-ray observations expose processes that shape galaxies from within, processes far too energetic for normal eyes to perceive. Then there are the radio telescopes. By tuning to the 21 centimeter line of neutral hydrogen, astronomers have traced the enormous reservoir of cold gas extending far beyond Andromeda's visible disk. These radio maps reveal structures you would never know were there: extended arms, outer rings, faint streams, regions where starlight grows too weak to guide us. And in these measurements lies one of the clearest signatures of dark matter. The gas at the outer edges orbits far faster than it should, unless an unseen mass is holding the galaxy together. Without radio astronomy, our understanding of Andromeda's true size, shape, and mass would remain fundamentally incomplete. But the real power comes from combining all of these perspectives. Overlay optical light with infrared ultraviolet, with radio X ray with visible. Instead of a single flat image, Andromeda becomes a layered organism, every wavelength unveiling a different facet of its life. The bright arcs of young stars, the dusty rings shaped by past encounters, the ancient halo stretching outward for millions of light years, the quiet flicker of high energy events at the core. Each piece contributes to a portrait not of a static spiral, but of a dynamic, evolving system. Meanwhile, the world's ground based telescopes have grown astonishingly powerful. Adaptive optics now correct for the blur of Earth's atmosphere, giving mountaintop observatories a clarity that once belonged only to space. Telescopes in Chile and Hawaii have mapped clusters in Andromeda with exquisite precision, tracing dust lanes, resolving knots of stars, and measuring motions across its disk. Wide field surveys have revealed its halo in unprecedented detail, exposing streams of stars, remnants of smaller galaxies, torn apart and folded into Andromeda's structure. Step by step, these advances have transformed the galaxy from a distant smear into a system rich with detail. Astronomers can now study individual stars in Andromeda, identify their chemical compositions, estimate their ages, track their orbits, and compare them to the Milky Way's own stellar populations. Thousands of star clusters, globular and open, have been cataloged. Each one carries clues about the galaxy's past, mergers, its cycles of star formation, its internal evolution. One of the most remarkable discoveries of recent years is the sheer size of Andromeda's halo. What we once assumed to be a relatively modest outer region has turned out to stretch across millions of light years, overlapping with the halo of the Milky Way. In other words, long before the two galaxies collide, their outskirts are already brushing against one another, sharing space, interacting through gravity in subtle ways. The future collision is not a distant surprise. It is the continuation of a relationship already underway. High resolution images make all of this tangible. When you look at a detailed photograph of Andromeda, millions of stars resolved into sharp points, the scale becomes real in a way that numbers alone never can. You see the densely packed bulge where stars crowd tightly together. You see the arcs of the spiral arms. You see dust lanes slicing across them like scars. You see the patterns, the rhythms, the complexity of a galaxy alive with motion. These images are more than data. They are windows. They bring a galaxy into focus, collapsing the distance into something the mind can hold. And yet, even with all this clarity, Andromeda keeps its mysteries. The best telescopes show us only part of its story. The deeper layers, its oldest stars, its earliest epochs, its hidden structures, still lie beyond our reach. But with instruments like the James Webb Space Telescope and future observatories beyond it, we are stepping closer. Webb's infrared vision is already peeling back the dust, revealing star-forming regions and ancient populations the Hubble could not see. Every new telescope adds a layer, revealing more than the last sharpening our sense of what Andromeda is and what it has been. Still, for all of this progress, The naked eye view has barely changed. Step outside, under a dark sky, look toward the constellation, and Andromeda appears exactly as it did to ancient observers, a faint, silent blur. The galaxy has become one of the most deeply studied objects in the universe, yet, to your eyes, it remains humble and ghost like. That contrast between what we know and what we see is part of its quiet beauty. Modern astronomy has transformed our understanding, but it hasn't erased the ancient experience. The blur remains, the mystery remains, and through that mystery, another truth emerges. Even across 2.5 million light years, Andromeda is not frozen in place. It is not stationary. It is moving. It is coming toward us. The measurements leave no room for doubt. Andromeda is not drifting randomly through space. It is following a slow, deliberate trajectory, one that leads directly toward us. A journey measured not in human years, but in cosmic ages. The question is never if the two galaxies will meet. The only question is when. And with astonishing precision, astronomers have already traced its motion, mapped its speed, and outlined the distant future when the Milky Way and Andromeda finally converge. The evidence comes from the light itself. When astronomers spread Andromeda's starlight into a spectrum, they find that its wavelengths are shifted slightly toward the blue, a compression caused by the galaxy moving closer to us. Most galaxies, carried by the expansion of space, drift away in a red-shifted haze. Andromeda is one of the rare giants doing the opposite. Its gravity and the gravity of the Milky Way override cosmic expansion on local scales and pull the two spirals inexorably together. Right now, Andromeda is moving toward us at about 110 kilometers per second. It sounds fast, but across 2.5 million light years, that speed is a gentle crawl. The first true contact will not come tomorrow, nor in 1,000 generations, but roughly 4 billion years from now. At human scale, that span feels infinite. At the galactic scale, it is simply the next interval in a long chain of motions. To picture this collision, we must first let go of our instinctive ideas about what a collision means. Galaxies are not solid masses. They are oceans of stars with enormous distances between them, so much space, in fact, that even when two spirals interpenetrate, almost no stars physically strike one another. Instead, the transformation comes from gravity, the quiet, relentless reshaping of orbits, the stretching of arms into long tidal streams, the compression of gas clouds that ignite new bursts of star formation. Simulations show how the process unfolds. As Andromeda approaches its vast halo of dark matter and stars overlaps with our own long before their disks touch. Over millions of years, the faint blur we see today would grow on the sky, swelling from a soft smudge into a dominant structure spanning many degrees. Eventually, the two galaxies pass through each other like waves intermingling. Spiral arms warp and twist. Enormous arcs of stars are flung outward into intergalactic space. Gas clouds collapse, and blaze into life. Then, as gravity draws the two systems back together, they merge once more, spiraling inward until they dissolve into a single shape. The final form will not be a spiral at all, but a massive elliptical galaxy, a smooth, rounded system born from the ashes of two spirals. Some call this future galaxy Milkdromeda, a name blending both lineages. Whatever we choose to call it, it will be larger, heavier, and brighter than either of its parents. For Earth and the solar system, the collision is not expected to be catastrophic. The distances between stars are so enormous that our Sun is unlikely to collide with another. Instead, our entire solar system will simply be carried onto a new orbit within the merged galaxy, like a small boat caught in the currents of a much larger tide. The skies, however, will change dramatically. Instead of a faint band of the Milky Way future beings, if any exist, we'll see arcs of stars from two galaxies woven together, forming patterns no human has ever witnessed. Deep within the centers of both galaxies, another meeting will unfold. The Milky Way's central black hole, 4 million solar masses, will eventually spiral toward Andromeda's much larger one, more than 100 million solar masses. Their slow inward dance will release gravitational waves, ripples in space-time, that sweep outward across the cosmos. Long after humanity is gone, perhaps long after Earth itself has changed beyond recognition, these ripples will carry the memory of the merger to distant galaxies. Thinking about this future forces us to confront the contrast between human time and cosmic time. 4 billion years feels impossibly remote. Our civilizations rise and fall in mere centuries. Our species itself is only a brief moment in Earth's long history. Yet 4 billion years is also the span that brought Earth from a molten world to one filled with oceans, forests, and life. Imagining that far ahead is not about predicting human experience. It is about recognizing how galaxies change slowly, patiently, in rhythms far beyond our own. There is a strange comfort in that. The collision is inevitable, but it is not violent in the way we imagine. It is slow, gradual, a dance that unfolds over timescales so vast that no single moment defines it. Stars continue shining, planets continue orbiting, the galaxies blend as if moving through honey, forming new shapes while preserving their underlying continuity. Andromeda's approach reminds us that the universe is never still. We often picture galaxies as perfect, unchanging spirals frozen in isolated beauty, but they are living systems migrating, interacting, merging. The Milky Way has already consumed dozens of smaller galaxies. Andromeda has its own history of absorbing companions. Their future collision is simply the next chapter in a long narrative of cosmic growth. In the grand web of the cosmos, galaxies collide, clusters merge, superclusters shift over billions of years. Everything is in motion, everything is evolving, and we living on a small world around a small star are part of that movement, whether we realize it or not. When we place ourselves against this future, we once again encounter the contrast and the harmony between human time and cosmic time. A collision to us is sudden and destructive, but to a galaxy, a collision is gentle, inevitable, and almost serene. What feels like a universe shaking event from one perspective is from another simply the quiet continuation of a cosmic story billions of years in the making. Andromeda's slow approach is not the promise of a cosmic disaster, but the beginning of a transformation already unfolding. The galaxy you see as a faint whisper in the sky is not simply drifting toward us, its motion is part of a long, deliberate process that will eventually reshape the entire local group into a single, larger cosmic structure. Knowing this adds a new layer of meaning to its delicate glow. The light that reaches your eyes tonight began its journey millions of years ago when Andromeda was slightly farther away than it is now. And every night, new photons arrive, each one carrying the quiet message that the galaxy is still moving, still closing in the distance. It is almost as if the universe itself repeats a reminder across the dark change is always coming, even when that change lies billions of years ahead. To reflect on Andromeda's journey is to glimpse the scale of cosmic patience. Nothing rushes, nothing surprises. The future is already written in the shared gravity between the Milky Way and Andromeda. Their meeting is not something waiting to happen, it has already begun. From here, it becomes natural to wonder what the sky will look like when the great merger is underway. What scenes will fill the heavens for any beings who exist billions of years from now? What will the collision appear like to eyes that look up from whatever world remains or whatever world takes Earth's place? To imagine that future is to step entirely outside human history. 4 billion years from now, the night sky will be transformed beyond recognition. The familiar soft band of the Milky Way will no longer be the sole dominant structure overhead. Andromeda, today, a faint smudge, will have grown into an immense presence, evolving year by year, generation by generation. At first, long before anything touches, Andromeda will simply look larger. Barely perceptible at first, its oval will slowly expand. Over millions of years, it will grow until it rivals the moon in apparent size. Then, larger still, to observers of that distant era, the galaxy will no longer be subtle or shy. Its spiral arms will unfurl across the sky, visible without any telescope at all, a living whirlpool of light suspended above them. Imagine standing under such a sky, seeing two spiral galaxies at once, the Milky Way's structure stretching across the darkness, and Andromeda rising beside it, bright and intricately detailed. It would be a sight so beautiful and overwhelming that even describing it feels inadequate. As the galaxies draw closer, gravity will begin to reshape them. Their once symmetrical arms will warp and stretch. Long tidal tails, vast rivers of stars, will be pulled outward, forming arcs that span enormous distances. For future observers, these tidal streams will appear as brilliant new streaks carved across the heavens. No longer will the sky look consistent from generation to generation. It will be filled with shifting patterns of light slow motion fireworks drawn by gravity itself. The Milky Way will gradually lose its familiar band-like appearance. Instead, the sky will become a woven tapestry of overlapping arms and glowing clouds from two merging giants. And yet, despite the breathtaking visuals, the process will be surprisingly gentle for individual stars. The distance between stars is so enormous that direct collisions are extraordinarily unlikely. Instead of smashing together, the stars of both galaxies will slide past one another, their orbits redirected, but their existence unharmed. The drama is in the arrangement, not the destruction. The solar system may simply drift into a new position, carried along by the great galactic currents. Where the true fireworks ignite is in the gas. When immense clouds of gas collide, they compress, triggering powerful bursts of star formation. Newborn stars, hot, brilliant blue, will appear across the sky in dazzling numbers. Nebulae, larger and brighter than any we know today, will glow like cosmic lanterns, vast regions of starbirth ignited by the merger. To beings alive at that time, the heavens will blaze with fresh light, a cosmic rebirth unfolding overhead. The galaxies will not merge in a single moment. Instead, they will pass through one another, pull apart, and fall back together, an elegant spiraling dance lasting hundreds of millions of years. Each encounter will send out new ribbons of stars, new arcs, new shells curving across the sky. For any species that exists across these ages, the night sky will be a living organism shifting slowly, deliberately across their lifetimes. And through all of this, the solar system may remain intact, gently guided into new orbits by the changing gravitational landscape. Future beings will witness a universe in motion, not from the perspective of cosmic telescopes, but with their own eyes. The familiar constellations will dissolve, new patterns will form. The sky will tell a story of two galaxies becoming one. For them, the heavens will never be still, and in that constant change, they will see what we can only imagine, the slow unfolding of one of the most magnificent events in the cosmic story. Eventually, after billions of years of drifting, stretching, warping, and settling, the Milky Way and Andromeda will no longer be two separate spirals, but a single merged galaxy. The elegant arms that once defined both will fade, replaced by a smooth, rounded form, a giant elliptical glowing softly in all directions. From inside this future system, the night sky will look nothing like ours. Instead of a narrow river of starlight arcing across the darkness, a dense luminous haze will surround future observers on every side. The familiar identity of the Milky Way will dissolve, replaced by a new entity often nicknamed Milkomeda or Milkdra, a cosmic fusion written by gravity itself. For any beings who look up then, the sky will carry an unfamiliar beauty, a new story unfolding above them. To imagine this future is to acknowledge that the Andromeda we see tonight, the faint blur, the spiral arms, the bright core, is only a temporary shape. Every feature we admire today is a phase in a far longer evolution. Our current view is just one frame in an ancient, ongoing dance. The true immensity of Andromeda is not only measured in its size or its trillion stars, but in its destiny. What we see now is simply a moment in a much larger transformation, one that will reshape the entire local group into a single gravitational family. And this future will unfold regardless of whether Earth remains habitable when it arrives. 4 billion years from now, the Sun will be entering its red giant phase, transforming our planet's conditions completely. Life as we know it may not survive, but perhaps other worlds will bear witness. Perhaps other beings will look up and watch the galaxies merge. Or perhaps descendants of humanity scattered across new homes will carry the memory of what the sky once looked like. Computer simulations allow us to preview that distant future. In accelerated time lapse, we watch Andromeda and the Milky Way drift closer. Their arms twist their stars, scatter into long, shimmering tidal streams. The vision is mesmerizing, like watching an ancient cosmic choreography unfold in moments. These simulations remind us of a deep truth. The universe is never static. Even the most majestic structures we see through telescopes today are temporary. The spiral elegance of Andromeda will vanish, but something new will take its place, a vast elliptical galaxy shaped by the creativity of gravity, written over billions of years. For now, the merger exists only in prediction, a vivid portrait painted by physics and observation. But the fact that we can predict it is astonishing. By reading the faint shift in light, by tracking motions across unimaginable distances, by modeling gravity with exquisite precision, we can forecast events billions of years ahead. We cannot predict our own weather a month from now, but we can foresee the destiny of two galaxies with remarkable confidence. That certainty is a testament to how deeply we have come to understand the cosmos. And so, when you look at Andromeda in the night sky, you are not only seeing what it was millions of years ago, you are also seeing what it will become. Its light carries memory and destiny at once. The faint glow is not a still object. It is a participant in a cosmic story still unfolding. Andromeda is not unique in this. Mergers happen throughout the universe. Every large galaxy has grown by absorbing smaller ones, blending their stars and histories into something new. The future of Andromeda mirrors a process written into the fabric of cosmic evolution. Which brings us to the question. We began with how big is Andromeda really? At first glance, the answer seems simple. Its diameter about 220,000 light years. Its mass more than 1 trillion suns. Its stars perhaps close to 1 trillion. These numbers are immense, but they point toward a deeper realization. At galactic scales, size becomes slippery. The numbers grow beyond anything the human mind evolved to grasp. They become symbols rather than sensations, quantities we can recite but cannot truly feel. On human scales, size is intuitive. A mountain is large, a house is small. But when we lift our eyes to galaxies' clusters and the cosmic web, our everyday logic dissolves. The cosmos forces us to stretch our sense of scale into realms where our ordinary intuitions simply cannot follow. Even the Earth, 40,000 kilometers around, can still be understood with effort because we can circle it, map it, see its curve from orbit. Our instruments can measure it with units that feel tangible, familiar. But a galaxy lives in an entirely different category of scale. A single light year, the smallest unit astronomers use for galactic distances, is already far beyond lived experience. Nearly 10 trillion kilometers wrapped into one number. So when we say Andromeda spans 200,000 light years, we are speaking in distances so large that the human mind cannot hold them directly. We can only approach them sideways through metaphor, imagination, or analogy. Imagine light itself, the fastest traveler in the universe, moving non-stop for an entire year. That distance is 1 light year. Multiply that by 200,000, and you begin to sketch the width of Andromeda. It's a number that slips through the fingers of intuition, a quantity we can recite, but cannot feel. And yet astronomers must describe galaxies somehow. They need the language of size because they need a way to compare, classify, and map the cosmos. Some galaxies are dwarfs only a few of 1,000 light years wide. Others are titans stretching 500,000 light years across. Andromeda stands on the larger side of that spectrum, not the biggest, not the smallest, but large enough to overwhelm our intuition and small enough to remind us that the universe contains structures far bigger still. But what does it really mean to compare one galaxy's size to another? Does saying that one spiral is twice the width of another tell us what it feels like to exist inside them? Not really. At these scales, size becomes a kind of shorthand. A galaxy's diameter hints at how far its disk extends, how long its spiral arms sweep, how much space its stars and gas occupy. Its mass hints at how strong its gravitational influence is, how tightly it holds its satellites, how rapidly stars orbit around its core. But these numbers are summaries, abstractions, clues pointing toward a reality too complex to compress into a single figure. When we say Andromeda is this big or that massive, what we really mean is that it occupies a region where its gravity rules, a domain of influence, a zone in which its stars belong to it. The size is a proxy for something far richer than any number can capture. It's also important to remember that galaxies do not have crisp outlines. They fade gradually into halos of stars and oceans of dark matter. So, where exactly is the boundary? At the edge of the visible disk, at the farthest detectable stars, at the point where gravitational influence starts to weaken. Different choices yield different answers, which means even the familiar 220,000 light year figure is not a fixed truth, but a convention, a practical line drawn around something that is fundamentally fuzzy. When we ask about size, we're really asking about perspective. Imagine an observer living inside Andromeda on a planet circling one of its stars. To them, the galaxy would feel enormous, but also invisible, exactly as the Milky Way does for us. They would see a glowing band across their sky, but not the spiral shape directly. They would have to infer it, model it, measure it exactly as we have done. For them, their galaxy's size would not be an experience. They would never stand somewhere and see its full boundary. It would be an idea built from evidence. At galactic scales, size is not something beings live inside of. It's something they calculate. And that leads to a deeper insight. Maybe at this scale, size isn't the most meaningful measurement at all. Andromeda is not just 200,000 light years wide. It is a spiral structure with arms shaped by density waves. It is a bulge surrounding a massive black hole. It is a halo littered with remnants of galaxies it once consumed. It is a gravitational partner of the Milky Way. It is a system with satellites, streams, collisions, and a long evolutionary history. Its immensity is not only in its physical width, but in its relationships, how it pulls, merges, influences, and transforms. Numbers can describe its dimensions, but they cannot contain its story. And consider the role of time. Andromeda is not frozen. Its stars migrate, its arms shift, its satellites orbit. Across billions of years, its shape changes. Its future merger with the Milky Way will rewrite it entirely. If we freeze it at one number one diameter, we lose the truth that the galaxy is always evolving. To speak of its size is to take a still photograph of something alive. Size is not static, it is a moment caught in motion, and everything at this scale is relative. Compared to a human being, Andromeda is unfathomably enormous. Compared to the Milky Way, it is somewhat larger. Compared to giant ellipticals in galaxy clusters, it is small. Compared to a supercluster, it is microscopic. Nothing is large or small in isolation. Size only exists in comparison, in relationship and context. And yet, despite all these limitations, the human mind continues to ask how big, how many, how far. These questions are part of how we anchor ourselves in the cosmos. They give us a handle on immensity, even if the handle is small and imperfect. They allow us to translate the unfathomable into something our minds can at least approach, even if never fully grasp. To ask how big Andromeda is will never give a clean final answer, but it does open a doorway into wonder, into spaciousness, into the recognition that whenever we try to measure something cosmic, our questions stretch beyond their familiar boundaries. The very act of asking is a sign of our curiosity of the mind reaching beyond itself, trying to grasp something it cannot fully hold. So perhaps size is meaningful, but only as a beginning, a starting point for a much larger contemplation, a way of pointing toward immensity rather than defining it. When we say Andromeda spans 200,000 light years, what we're really saying is, here is something vast, larger than anything you will ever touch, yet still part of the same universe you inhabit. The number is both precise and insufficient, both helpful and incomplete, a window, not the landscape itself. And when the night is clear and still, you can step outside and remember that you are standing beneath not just stars, but galaxies. The Milky Way arches across the sky, a river of light from within our own home. And off to one side, faint and easily missed, lies Andromeda. To your eyes, it's only a soft blur, a whisper of brightness among sharper stars. And yet, within that blur lives an immensity greater than our own galaxy. Nearly a trillion suns woven into spirals and streams, drifting toward us across a gulf of space so wide that light itself travels for millions of years before reaching you. It's extraordinary to think that this faint smudge has carried such weight in human imagination. For centuries, it was only a mystery, a patch of light noticed, but not explained. Then came the age of telescopes, the revelation that the universe was far larger than we ever imagined. And now, with modern instruments, Andromeda becomes intricate, its arms traced in starlight and dust, its halo stretching outward. its satellites surrounding it. We measure its mass. We map its motion. We simulate its future. We predict its merger with the Milky Way billions of years from now. But when you stand beneath it, none of that is required. The experience is enough. You know it is vast. You know it holds stars beyond counting. You know it is slowly approaching us through the deep fabric of space. But in the quiet moment of looking, all of that dissolves into a single, soft glow, a reminder that the universe contains more than the eye can see, more than the mind can hold. It invites you to pause, to breathe, to let the scale wash through you without needing to solve anything. Immensity does not ask for mastery. It offers perspective. To fall asleep beneath such a glow is to carry that perspective inward, to let your mind drift on the scale of galaxies, to picture their arms moving through space like slow tides, to imagine their stars orbiting their black holes, anchoring their centers, their histories unfolding across billions of years. You can imagine Andromeda as it is now, as it was when its light left its stars, and as it will one day become when it merges with our own galaxy. The mind cannot contain all of that at once, but it can wander through the pieces gently. Stars, dust, halos, streams, collisions, shapes shifting over time, a rhythm of immensity that settles the breath. There is a quiet comfort in remembering that galaxies move on time scales so long that our own worries, urgent, sharp, immediate, become small beside them. Not unimportant, but softened, given context. The things that weigh on you today live inside a universe whose timelines stretch billions of years. To sleep under Andromeda is to let that wideness ease the edges of thought, to remember that you belong to something far larger than this moment. Andromeda isn't only out there in the sky, it is also inside you. The carbon in your cells, the oxygen you breathe, the iron in your blood, all were forged in stars like those that fill Andromeda. You are made of the same material, shaped by the same cosmic cycles, born from the same universal processes. When you reflect on that, as you drift toward sleep, separation dissolves. You are not just looking at a galaxy. You are an expression of the same universe that formed it. And long after you close your eyes tonight, long after you wake tomorrow, long after humanity itself is a distant chapter in cosmic history, Andromeda will continue. Its stars will rise and fade. Its arms will shift. Its collision with the Milky Way will reshape it. But tonight, its light has reached you. Photons that traveled millions of years to end their journey in your eyes. That alone connects you to something vast and ancient. You are part of its story simply by seeing it, simply by knowing it, simply by letting it settle in your mind as your body settles into rest. So as you lie down and feel your breath slow, imagine that faint glow above you. Imagine its arms sweeping wide, its stars uncountable, its future immense. Let it remind you that you are small, but never separate, brief, but never irrelevant, a living moment inside a universe that goes on endlessly. And as sleep comes, carry that glow with you, the glow of a trillion suns, the glow of a galaxy drifting gently toward us, the glow of the cosmos reflected in your quiet thoughts. It is not just light in the sky, it is a companion in the night, a reminder that even in darkness there is always more, beyond, always something larger, always a reason to look upward, even if only in memory as you drift into dreams. Thank you for spending this time under the stars. If these reflections brought you calm, you're welcome to return any time to let the universe keep you company again. For now, may your night be peaceful, may your thoughts grow light, and may sleep arrive softly, carrying you into dreams with the quiet shimmer of galaxies.